Supercars, an extraordinary combination of heady engineering, hardcore science, and nearly mythical art that comes together in a single high-performance package.
There have been supercars almost for as long as there's been the automobile.
Machines that break convention, push the boundaries, and live on the bleeding edge of mobility.
Supercars are exclusive, they're high performance, they're everything we think exotic cars should be.
From their primordial forms through their latest and greatest state-of-the-art variants, key bits of kit and crucial tech have transformed motorized carriages into rocket ships for the road.
One of the reasons technology has been so important in the evolution of a supercar is that it's enabled practically anyone to drive it.
This is the story of mankind's relentless pursuit for speed, the remarkable machines that brave the way, and the amazing evolution of supercar tech. Today's supercars are remarkable pieces of advanced tech that stir the soul and capture the imagination.
Supercars are these haloed, ideal vehicles. They are things we hang on our walls. They're aspirational. They're pieces of automotive history that just connect with us in a way that's emotional.
They're machines that live on the bleeding edge, where high-tech merges with high performance in a battle of physics.
I would define the evolution of a supercar as a vehicle that's gone from being capable of driven only by professionals to something that practically anyone can drive thanks to technology.
Special cars devoted to high performance and extreme design have been a hallmark of the automotive industry since its inception over 130 years ago.
So when somebody says supercar to me, I think of technology. I think of engineering. It has to have some new technology. It has to sort of push the forefront of technology. It has to be on the vanguard of technology. It also has to have a lot of power. Some of it's design, too. A supercar has to be striking. Supercars get a super reaction from you, whether it's like, wow, or that's beautiful. A strength in engineering, it's a strength in what its engine is. It's sort of a vision of the future before the future happens.
A vision of the future that showcases an automaker's ability to stretch every aspect of design, engineering, performance, and technology without the constraints of mass economies of scale.
A supercar is the best of what a company can do in terms of engineering and design and luxury and everything.
Extreme performance, that's what it's all about.
Supercars push the envelope while occupying a realm of pure fantasy.
They become part of the automotive myth of what a true, perfect vehicle looks like.
They're a potent cocktail of innovation, power, and sexiness, all rolled into one piece of glorious mechanical art.
Engineers and technologists in today's supercar era are looking to continually push the envelope, and it can be a matter of a few miles an hour, it can be a matter of a few tenths of a second faster. And as we get to the very pointy end of performance, that's going to become a higher and higher stakes race.
Today's high-stakes race to build the ultimate supercar has very humble origins. It traces all the way back to mankind's quest for mechanized transportation, which begins in the late 19th century.
In the earliest days of automotive history, there really wasn't anything resembling a supercar. Cars were just meant to get down the road.
At the time, numerous inventors raced to create the world's first viable form of mechanized personal mobility.
Most people didn't go more than a few blocks from their house on any sort of regular basis. So the world was completely different and unprepared for the automobile. The automobile had to create the world that it could exist in.
From the outset, the car industry becomes a beacon for forward-thinking engineers interested in emerging tech. It's a mechanical gold rush that's not all that different from early Silicon Valley.
Early on in the automobile's development, there were steam cars, there was the internal combustion engine, and there were electric cars. And all three were competing at the same time. People were just trying to figure out what was going to work for the future, and nothing was set in stone.
In 1886, a German engineer decides that while horses are good, harnessing horsepower is even better. His name is Carl Benz, and his invention will reshape the world as we know it.
Carl Benz had the dream of creating a horseless carriage. His idea was an engine-powered vehicle, but there was no engine nor a suitable car to put it in. He started from absolutely scratch.
When Benz bolts a single-cylinder combustion engine onto a three-wheeled carriage, the trajectory of personal travel shifts forever. He names his invention the Benz Patent Motorwagen.
The 1886 patent wagon is widely regarded as being the first car.
It can lay claim to effectively inventing the modern automobile. If any single car company can be tied with the history of the automobile from start to finish, or start to today, then it would be Mercedes-Benz.
The Motorwagen ushers in the automotive age. The machine is so revolutionary that it actually predates the word automobile itself.
It's a little three-wheeled thing. You wouldn't really necessarily think of it as a car. It's more of a carriage.
And it seems like they're important cars for every phase of automotive history. 1886 Benz was important.
I can only imagine the impact that the Motorwagen had when it dropped in 1886. At the time, the only way to get around was by walking, or riding a bicycle, or a horse and carriage, or a train.
The three-wheeler features a single-cylinder four-stroke engine that makes just 9/10 of 1 horsepower and weighs a mere 100 kilograms.
There was no infrastructure, there were no roads suited for these cars. The idea of a car was brand new. I really cannot emphasize enough how revolutionary this was for not only personal mobility, but the human race and the progress it made in the ensuing century.
The patent Motorwagen helps mobilize humanity, yet it's the early iteration of the internal combustion engine that will ultimately be the most transformative.
It was man's ability to basically be self-propelled. The gasoline car gave a lot of freedom to people.
These were objects, the power of which you had in your hand, or you had at your foot. They were entirely up to you. You didn't have to worry about feeding it oats. You didn't have to worry about it getting sick, at least organically. You didn't have to worry about it getting worn out. The cars didn't do that. So people thought, you know, we can have fun with these cars.
Internal combustion engines are more reliable than organic forms of transportation. Even though they're relatively small and lightweight in size, they're capable of generating vast amounts of power. Now all kinds of practical applications, ranging from early airplanes to handheld chainsaws, are possible.
The early ones were noisy and loud and very unreliable, but gasoline was readily available. Eventually they figured out a lot of the early teething problems, and you could get a car that would run quickly and run well, and you could get from point A to point B without a horse.
The emergence of combustion tech results from the confluence of two major societal shifts: easily available petrol and more accessible precision machining.
The development of the internal combustion engine is a byproduct of the development of modern machining and modern machining abilities. It wouldn't exist without it. Well, that ability didn't really exist in the middle of the 19th century. And so the ability to measure an inch to the 10th of an inch, to the 100th of an inch, to the thousandth of an inch, the creation of this ability is really what allowed engines to be developed, because an internal combustion engine depends on very tight tolerances.
Internal combustion engines work thanks to four key principles. First, air is drawn into a cylinder. When the piston moves up, it squeezes the air and fuel together. Then, a spark ignites the compressed mixture. The resulting explosion pushes the piston down, propelling the machine forward before the return stroke releases the exhaust gas.
This idea of you would use 4 strokes, this was really going hand in hand with the development of precision machining, because a car engine depends on your ability to measure things to a very highly accurate degree.
While the patent Motorwagen is a game changer, it's also an embryonic version of a car. The machine doesn't even have a steering wheel, because like the word automobile, it hasn't been invented yet.
It blew people's minds. It was amazing. Where's the horse? This thing moves? How does that happen? Today, if you look at a 900 horsepower Ferrari, it blows your mind. It's stunning. How does that work? So in a sense, they're related. You know, the automobile technology march has continued to produce things that astound.
Numerous investors try to perfect Benz's initial idea. However, the format of the automobile doesn't truly crystallize until 1901, when an Austrian businessman named Emil Jelinek asked the Daimler Motor Company to build him a very special machine.
Well, Mercedes-Benz have always had their unique stamp in automotive history.
The result of the request is the Mercedes 1901, a machine that's often recognized as the very first proper motor car.
It had a low center of gravity, a pressed steel frame, a light and high-powered engine, and a honeycomb radiator. With these features, it is regarded as the first modern automobile.
In a single masterstroke, the 1901 defines the basic layout that the vast majority of 20th century cars will use. It uses a pressed steel chassis with a low-mounted high-performance engine, which combines to give the machine a low center of gravity. The 1901 also features seats for occupants, a steering wheel, and a honeycomb radiator integrated into the front of the vehicle.
It was enough just to make them go down the road. And then there came a time where people said, you know, we could have fun with these things. It's kind of cool having all this power at your disposal without it being an actual horse in front of you.
While the 1901 creates the template for the modern automobile, it'll take a Midwestern farmer to bring it to prominence, and a group of British aristocratic playboys to push the boundaries of speed. Today's supercars are wickedly fast and sublimely engineered high-tech marvels that push the boundaries of our imagination.
But that's what supercars are about, meeting one extreme and then taking it to another. And then you meet that extreme and you take it to another. There's always development possibilities. It's up to the technicians to explore those possibilities and make them viable for a passenger automobile.
Amazingly, the technical evolution of the supercar owes much of its success to the ordinary automobiles that first helped mobilize humanity.
The story of transportation is the story of movement of humans and human connection, ultimately, and it's a matter of sort of how you get from point A to point B.
During the early part of the 20th century, moving great distances by car is nothing short of revolutionary. People no longer have to rely on horse-pulled carriages to travel. Yet the burgeoning field of motorized transportation is still in its infancy.
When you go back and read magazines like The Horseless Carriage in 1906, all of the drivers were wealthy by and large because that's the only people who could afford cars. And they were primarily interested in driving for pleasure.
The machine that levels up the automobile forever is the 1908 Ford Model T.
The Model T is critical to automobile history.
Ford is the company that put the world on wheels.
It's easy to make the case that this single machine is the most important car of all time.
When the Model T was introduced by Ford Motor Company, it was a huge change in the social fabric of America and the world. It gave the common man an ability to go beyond a 20-mile radius from home.
The Model T is the vision of just one man, Henry Ford. The son of a farmer, he imagines a future where everyone can own their very own car.
Prior to Henry Ford with the Model T, the horse was the main means of transportation. And that was a constraint, of course, on everyone's lives. But just to think in the morning, I'm going to go see Aunt Mary 100 miles away, you couldn't do it.
The Model T made motoring affordable to the average working man. The notion of a family car was born with the Model T. It didn't exist before then.
The inexpensive nature of the machine will ultimately help usher in the supercar era.
Affordability mattered hugely in the early years because without popular demand for cars, you wouldn't have the infrastructure or the great industries that then went on to produce the supercars. It's all one ecosystem. I would say you absolutely could not have a LaFerrari without the Model T. They are directly interconnected.
The Model T also moves the game along thanks to its use of interchangeable parts. At the time, most pieces of a car are individually built, which means each vehicle is completely bespoke. Ford decides to build his parts to exacting specifications that allow them to fit into any number of identical versions of the same vehicle.
At the dawn of the automotive age, the earliest beginnings of interchangeable parts, of mass production, these were already underway, and the automobile slotted into that because it's so many parts in a car compared to most of the other machines out there at the time.
According to legend, in order to keep costs down, Ford insists that his suppliers deliver their parts in wooden crates, which he breaks down and repurposes as planks in Model T pickup truck beds. It's one of the earliest examples of automotive sustainability on a mass scale.
There's been enough development. Why don't we make sports cars? Why don't we make cars just for the sheer joy of driving them?
The speeding ticket was invented the day after the automobile because the towns hated the cars coming through so fast.
While the Model T focuses on utilitarian transportation, in another corner of the car industry, other engineers aim to heighten the pleasure of driving. Perhaps the best example is the 1913 Mercer Type 35J raceabout.
A lot of people think of the Mercer as the world's first sports car, well, at least America's first sports car. That's because it was maximum performance with minimum comfort.
Widely considered one of the first purpose-built sporting cars, the Mercer 35J features a unique T-head engine that sits in a well-balanced chassis.
What the Mercer raceabout shared with its stablemates was a fairly large T-head four-cylinder engine, which was, in its day, almost as exotic as it got. It had a very low-slung chassis, a chassis that barely fit over the axles to keep it low.
The 35J's performance is absolutely striking. It's been less than 3 decades since the invention of the automobile, and the raceabout is already hitting a 90-mile-per-hour top speed.
That was really something. That would have made the Mercer the Lamborghini of its day. Way more carved than even the roads were capable of handling.
Outright speed isn't the Mercer's only supercar-like trait. It's also one of the very first machines to place importance on design.
That's another part of being a supercar, is the look. You have to have the look. What good is spending a lot of money on a vehicle or anything really and going out and about with it and expressing yourself if nobody knows what you have?
While the Mercer causes a sensation, another highly exotic bit of machinery blazes a new technological trail: the dual overhead camshaft.
The development of the overhead camshaft, which goes right back to the dawn of the automotive age.
The main benefit of a dual overhead camshaft is that it allows an engine to use 4 valves per cylinder. Each camshaft operates 2 valves. One handles the intake, while the other operates the exhaust. And the combination allows an engine to run at higher speeds, which creates even more power and performance.
We know from basic physics that it's easier to spin something than it is to reciprocate something. So if you're going to reciprocate something, meaning it's going to go back and forth, you have to start it, accelerate it, stop it, and reverse its direction. Whereas if you spin something, it just spins.
The Peugeot L76 is the first vehicle to feature dual overhead camshafts, and it pays off. The car wins the 1912 French Grand Prix. Amazingly, over a century later, you can still find the same basic tech in the humblest economy machines.
Instead of having push rods actuate the valves, with the notion that if you replace that with something that spun that could then actuate the valves, you would have access to much higher engine speeds and thus more horsepower.
Ah, happy memory. Just a few twists of the crank and there we are. All ready now, off we go.
Back in the day, starting a car is a labor-intensive task. It takes great strength to crank an engine by hand and is extremely dangerous. However, all that changes with the introduction of the 1912 Cadillac. It is the very first car with an electric starter.
And that set the template under which that sort of raised the bar to the point that they've been living under almost ever since, really. So their reputation was hard-earned, but very much justified.
The introduction of the electric starter not only takes the physicality out of driving, but is also a crucial step towards the high-wattage electrical systems found in today's most powerful supercars. And they owe a debt of gratitude to the 1913 Lancia Theta.
Lancia was famous for building these extremely capable and powerful, over-engineered cars that just could hold the road like nothing else.
Lancia is known for a lot of firsts. They've been characterized sort of as being an Italian Mercedes-Benz.
The Theta is the initial car to feature a complete electrical system.
Lancia were the mad scientists of the automotive world for a long time. They were this company that tried new things and really pushed the envelope in car technology for racing and for street cars.
While the machines of the early teens advance motoring, there's still one ordinary and everyday piece of tech that lags behind.
The primary struggle was one of infrastructure. There were no roads, effectively.
At the start of the 20th century, less than 10% of the industrialized world's roads are paved. The rest are dirt paths that frequently turn into muddy quagmires.
The roads that were there were extremely rough and way beyond what we consider a rough road today. I mean, they were trails. So the first motorists were constantly struggling against the elements.
Basic roads have been with us since Roman times. However, modern road construction techniques can be traced to a process developed by a Scottish engineer named John McAdam in the early 1800s. McAdam decides to build his roadbeds with multiple layers of soil and crushed stone aggregate before packing them down with a heavy roller, which creates a solid foundation that's more resistant to the elements.
And it wasn't until people had cars and later roads to drive them on that people were able to travel any distances with any regularity.
The rapid acceptance and installation of glorious asphalt will help push the progress of motoring. Yet it will take some daring and adventurous pilots to truly drive the evolution of the super sports car. Cars are a cornerstone of contemporary life that offer humanity the freedom of travel and allows people to move both goods and services great distances. Yet even from the automobile's earliest days, drivers have reveled in pushing their performance to see just how far and fast they can go.
It was very much a kind of this new invention that was really kind of a toy for exploring the countryside, because back then nobody traveled. I mean, if you didn't travel by ship or by train, you stayed in one place.
Early tech adopters ignore the limitations as driving for pleasure becomes a new pastime. And the more people get out on the road, the more they race.
Since the birth of the automobile, racing has been part of practically every manufacturer.
The 1920s are the era of the gentleman racer, when the rich drive for glory and car companies use racing to advance the science of the supercar.
They had huge technical challenges, which to some extent mirror the technical challenge that Silicon Valley had in the early days, because the technology wasn't there to achieve the dreams that they had.
If you're going to have a supercar, it needs to stand out not only in how it performs, but in how it looks.
Pushing scientific boundaries in cars is an expensive venture, back then and today.
The cars today seem like they're built to intimidate. It's like, I'm rich and I'm gonna flaunt it. You're just gonna have to live with my being so cool that I can afford this. Back then, wealth was quieter. Wealth expressed itself in bespoke products.
Perhaps the greatest bespoke automotive expression is unveiled in 1924. Some even call it the world's first supercar, the Bugatti Type 35.
The Type 35 was the car that put Bugatti on the map.
The Type 35 was a Grand Prix racing machine.
The Type 35 dominates the Roaring '20s like few others. It's one of the most successful race cars of all time.
Everything that came before it kind of came together in this cohesive shape, and it was just unquestionably perfect.
Really wonderful machine, a great all-rounder, powerful, charismatic, beautiful, fast.
The Type 35 stands out as one of the most effortlessly beautiful motor cars ever made, and makes a name for itself thanks to its advanced powertrain.
The Type 35 not only had the most fantastic gearbox of all pre-war racing cars, and was so easy to handle and had such a light steering, but it was in its entity, the package, which made it a joy to drive.
The machine weighs just 750 kilos and features a hollowed forged front axle to shave weight. However, the machine's crowning achievement might be its cast aluminum wheels, which improve handling and continue to be influential to this day.
We're talking about 40 years before the term supercar was invented, and you have this car that it's untouchable. And so if we want to take a look at the definition of supercar, a supercar, a car that can leap tall buildings in a single bound, faster than a locomotive. This was a supercar.
As French racers become a formidable force, a country away, the Germans pursue a different strategy with the Mercedes 28/95.
They took an engine that they were making for aircraft, World War I bombers and World War I fighter planes, and they adapted it for automotive use.
The machine uses a gigantic supercharged 7-liter inline 6-cylinder engine that generates nearly 100 horsepower. The 28/95 is also notable because it features Mercedes' first use of an overhead camshaft.
Here's a car with an aircraft engine. This is a car that could keep a heavier-than-air object aloft for hours at a time, harnessed to the ground. It was propelling a terrestrial object, which was utterly amazing.
While the 28/95's engine gets most of the credit, it's actually how the machine stops that gets the glory. It's the very first Mercedes to be equipped with brakes at all 4 wheels, a technical revolution that quickly becomes the standard in automotive engineering worldwide.
It has a Teutonic severity about its appearance that in its day, you could say it was a little bit feared. It was a very intimidating looking car, but that's what you wanted. You wanted to look intimidating. You were in a car that, frankly, was the king of the road.
Across the English Channel, the need for speed and the desire to prove it on the track helps inspire one of the greatest British motoring machines. The 1927 Bentley 4.5-liter.
You have the Bentley blowers. These things were just absolute beasts out there.
There have always been performance cars every decade. The blower Bentleys were sort of supercars of their day.
Throughout the early 1920s, Bentley racks up piles of racing victories. Yet by the back half of the decade, its clear competitors are closing the gap. Company founder W.O. Bentley's answer is to build a bigger and more powerful engine.
W.O.'s solution for creating more power was to just build a bigger engine.
While W.O. wants to enlarge his engine, a Bentley driver named Tim Birkin takes an alternative approach. He's part of a tight-knit group of gentlemen racers who gravitate towards racing and come to be known as the Bentley Boys.
Now, the Bentley Boys were this group of wealthy playboys, basically, that enjoyed racing, and they'd take their Bentleys and they'd go and race in these races like the 24 Hours of Le Mans, and they'd actually win.
The Bentley Boys took Bentley to racing glory in the 1920s. They drove Bentleys to the limit across some of the most famous racetracks in Europe, including Brooklands and Le Mans. And it was this group of gentlemen racers that really gave Bentley its performance heritage, and they won Le Mans with Bentley 5 times between 1924 and 1930.
Birkin sees the success that Bugatti and Alfa Romeo have on the track with supercharged machines and wants to use the same type of forced induction system on his Bentley.
The supercharged 4.5-litre Bentley, also known as the Blower, is one of the most iconic cars of Bentley's history. It was created by one of the Bentley boys, Sir Tim Birkin. He commissioned an engineer, Amherst Villiers, to design a supercharger.
A supercharger is a mechanical air compressor that increases the pressure or density of air entering an engine. When you force more oxygen into the cylinders, it means there's more potential energy to exploit when ignited.
A supercharger is a way to get more air into an engine. The more air an engine takes in, the more fuel it can use, the more power it can make.
The 4.5 blower isn't the first machine to feature a supercharger. However, it's perhaps the most important early iteration. When Tim Birkin installs a supercharger on his Bentley 4.5, it creates an additional 65 horsepower and rockets the machine to a second-place finish at the 1930 French Grand Prix.
At Bentley today, we still own one of those road cars and indeed one of the 4 team cars, which is the most valuable Bentley in history.
The blowers symbolize a powerful era of British motoring, and helped cement Bentley's place in the upper echelon of supercar constructors. Yet engineers continue to seek new and innovative solutions to unleash more power and better performance.
Going back to the start of the automobile, there have always been engineers and automakers who have been obsessed with getting the most powerful car.
The quest for speed is a common link that runs through all the automotive ages. However, the advancements found on the track are just starting to unfold. Some brilliant silver arrows will help launch the supercar to dazzling new heights. Supercars, machines that lead the way. They're the best of breed, and they offer technical glimpses into the future of four-wheeled transportation.
The supercar is just another expression of the feats of human engineering or the accomplishments of human engineering. A supercar is not just one component. It's the artful organization of several components.
Although the term supercar isn't officially christened until the 1960s, high-performance-seeking machines have been front and center throughout the entire rise of the automobile. From its early beginnings as a curious invention and across its remarkable evolution, all the way to its permanent place at the zenith of hyper-personal performance.
One of the things about supercars is there is an addictiveness that comes with it. It's like once you go to 100, you're like, okay, it's not so bad. It's like your fear threshold gets a little bit further out. They're all just pushing that envelope a little bit further, a little bit further.
Today's outrageously exotic machines are technically sophisticated bits of kit capable of exceptional high-speed feats. Yet the logic that underpins them is often based on the remarkable lessons learned at the track in the 1930s. A period of glorious road racing known as the Silver Arrow era.
The first Silver Arrow racing era started in the 1930s. It is almost unbelievable, but these Silver Arrows were as powerful and as fast as today's Formula One cars.
So you have these really fast German automobiles that the press labels Silver Arrows because of how competent they are at going high rates of speed.
The Silver Arrows are born thanks to an arbitrary rule. In 1932 in Paris, Grand Prix Racing's governing body decides to restrict the total weight of a race car to just 750 kilos.
Mercedes formed a lot of its reputation by going racing.
At the time, racing is a deadly business. Cars reach top speeds in excess of 300 kph and often outrun their capabilities. To reduce the danger, officials decide to create a weight limit. They believe manufacturers will only be able to use smaller, lightweight, and less powerful engines. Only the simple assumption is horribly wrong. It underestimates the continual march of technological progress.
These racing cars were way ahead of the time.
Two German car companies seize the opportunity. Both Mercedes-Benz and their arch-rival Auto Union, which will later rebrand as Audi, go all in to win.
In the 1930s, the Mercedes Silver Arrows were just completely dominant.
In 1937, Mercedes-Benz introduces the W125. It uses a supercharged straight 8-cylinder engine that produces a mind-boggling 646 horsepower and is more powerful than contemporary Formula One cars through the early 80s. The machine's primary competitor is another masterpiece of engineering, the Auto Union Type C.
The Auto Union Type C, the car in the back of me, 16-cylinder mid-engine, 6 liters capacity, 520 horsepower, and a torque of approximately 870 Newton meters.
The Auto Union Silver Arrows are perhaps the most influential machines of the era because they helped lay the foundation for today's supercars, thanks to their ingenious mid-engine layout, lightweight, and high horsepower powertrain.
Ridiculous low revs on 3,500 RPMs. The top speed of the single-seater is approximately 330, 340 kilometers.
While Grand Prix racing pushes speed and power to new heights, over in France, luxurious and exclusive high performance is also being redefined.
It's very hard to dazzle and amaze today with a supercar the way Bugatti was able to back then.
In 1934, Jean Bugatti designs a new machine that will combine elegance, quality, and performance in one unique technical platform, the Bugatti Type 57.
The Type 57 was the first technical platform for Bugatti. It brought financial success to the company.
It is the most beautiful, the most balanced, the most incredibly well-designed car of all the late 1930s supercars.
The machine's body uses an advanced aviation alloy that's comprised of 90% magnesium and 10% aluminum. It can't be welded, so the factory hand rivets the sheets together. However, the vehicle's epic advancement comes from its chassis.
The very first concept of a platform giving way for many different and very attractive body styles.
The most famous version is the Type 57 Atlantique. Just 4 are ever made, and today only 3 remain. This is one of them.
The Type 57 SC Atlantic was a combination of wonderful attributes all rolled into one thing.
This was the Bugatti Veyron before there was a Bugatti Veyron. I mean, it established Bugatti as this preeminent car brand that was the ultimate expression of Art Deco French design. The fact that there are only 3 and they're almost invaluable because they don't change hands very often.
As the Germans and the French work to advance their vision of a supercar, in America, another marque begins carving out its own unique version of high-performance motoring.
In the 1920s and 1930s, if you said you drove a Duesenberg, that was it. They were the Ne Plus Ultra, as good as it got car. This is a vehicle that embodied every technical innovation of its day, and not just in a tiny little engine.
The 1933 Duesenberg SJ is a supercharged 7-liter inline 8-cylinder powered rocket.
They took double overhead cams, 4 valves per cylinder, aluminum construction, and they scaled it up to 420 cubic inches for the Model J. All of a sudden, you had a car that had 265 horsepower when its nearest domestic competitor had 130 horsepower.
The Duesenberg SJ is so powerful for the day that early promotional materials state an owner can only be passed if they allow it. Yet the factory doesn't stop trying to up the ante and keeps finding new ways to eke out more performance.
A couple years later, they said, well, what if we experimented with the manifolding? And then they evolved a kind of manifold they call ram's horn induction. A couple of reports estimated that it turned 400 horsepower on the dynamometer. The engine was said to be so powerful, it would chew up the dynamometer. There wasn't a dyno that was powerful enough at the time to handle it.
While Duesenberg pushes technological advancement in the hopes of finding more power, back in France, the French government offers funding to inspire motoring success. The result is the Delahaye Type 145.
The Delahaye 145 was some special car. In the years before Ferrari came along with their V12 engine, Delahaye had a V12 engine.
The French government offers 1 million francs to any company that can beat the Italian speed record around a racing circuit outside of Paris. Delahaye answers the call with a 4.5-liter V12 powered Grand Prix racer.
V12 engines became darlings of the performance world because you had so many more power impulses per revolution of the crankshaft. And that greater quantity of power impulses gave a smoother delivery of power, more consistent power, and ultimately greater power.
Pilot René Dreyfus sets a fast lap average of 146.6 kph and takes back the speed record. Yet the machine's story is far from over.
After World War II, Henri Chaperon, a coach builder, got a hold of a couple of pre-war Type 145 Grand Prix chassis and said, you know what, let's make these road cars.
The repurposed Grand Prix cars quickly become super sports cars for the street.
This is a coach builder taking Grand Prix car and putting voluptuous coachwork on it. It's like taking a prize fighter and putting him in a tux.
The story of the supercar is the relentless pursuit to push the limits of science and speed. Yet it all comes to a halt on September 1st, 1939, when Germany's Nazi party invades Poland.
During World War II, the fun stopped. All of a sudden, all the technology was being diverted to perfecting machines of war.
During World War II, cars take a back seat to military needs. The smartest engineers are asked to build weapons of war. And the auto industry's focus is diverted to wartime materiel. Yet the hunger to produce stunning cars is never extinguished. The coming post-war years will reignite a global race to perfect super sports cars, and with them, the world's very first supercar.
There's this huge adoption of technologies going on. The first 50 years of the car took a long time and developed slowly, and it's been nothing like the second 50 years of the car, where the technology adoption is so much faster.
The search for speed is a hallmark of motoring throughout the ages. The foundation that early automotive pioneers forge changes society and sporty cars, which will one day be rechristened as supercars. The ultimate example of mankind's need to explore the limits of high-performance automobiles.
The movement from horse and carriage to the patent Motorwagen to the supercars of today is this progression of finding ways to get people to connect in physical space through automotive engineering and technology, and through the advancement of things like engines and transmissions and design, and our desire as humans to connect in a way across space that is engaging and fun.
Supercars, an extraordinary combination of heady engineering, hardcore science, and nearly mythical art that comes together in a single high-performance package.
Car companies like to compete with each other, and car companies like to show off. And a supercar can do both of those things.
They're machines that live on the cutting-edge frontier of mobility and inspire us to dream.
The term supercar is used normally to define cars with incredible performances, with incredible numbers, horsepower, top speed, acceleration.
Each and every mega-fast machine owes its existence to the remarkable discoveries and evolutionary steps taken in the past by brave engineers and daring pilots.
So you build this incredibly powerful car that, draws all the magazine covers, draws all the headlines. You sort of show who you are.
This is the story of mankind's relentless pursuit for speed, the remarkable machines that brave the way, and the amazing evolution of supercar tech. At the end of the 1940s, the world is reeling. It's been just 5 years since World War II, and most European automakers are struggling. The majority of their factories have been destroyed, and the global economy stands in ruin.
But after World War II, all of a sudden, you had an entire class, an entire category of engineers that said, wait a minute, we developed all this stuff for the military. Let's adapt some of that technology to the automobile.
As mankind puts the horrors of war squarely in the rearview mirror, it's finally time to throw off the shackles and rekindle a search for speed.
In World War II, the national speed limit was 35 miles an hour, and nobody thought it was a huge imposition. Your mother-in-law was in the back seat going, slow down, you're driving too fast. Are you trying to get us all killed? Nobody went faster than about 45, 50 miles an hour. That's the pace at which society went.
Throughout the war years, many drivers make sacrifices. Meanwhile, engineers push themselves to develop the most cutting-edge tech for the military. Now that the war is over, both are free to explore more moto-romantic pursuits.
Here is an entire industry's worth of engineers who knew now that they could do just about anything they wanted. All of a sudden, you had fuel injection. All of a sudden, you had disc brakes. Think about stuffing all of that great technology into the smallest possible vehicle and motoring down the road with it.
The need to go faster didn't really exist until after World War II. And then once the ability to go faster came around, the desire to go faster and the desire to have exclusive, exotic, foreign cars, that really, increased in the post-war prosperity. So that's really where Supercar has come from.
As the auto industry slowly rebuilds, the dire effects of the battlefield help spark an air of cautious optimism, which encourages new car constructors to enter the global stage.
After World War II, there were a couple of brand new manufacturers that the world had never heard of before. One of them was Saab, one of them was Porsche, and another was Ferrari.
One man who desperately wants to go faster is an Italian named Enzo Ferrari.
Enzo Ferrari was singularly driven by a desire to conquer his opponents on the track.
Ferrari could not have existed without him. It would not be the car company it is today without him at the helm.
This was a man who was on a mission. He knew nothing but racing. He developed, as a consequence, some of the fastest cars on the planet for any given era, if not the fastest.
Enzo establishes his own car company with the single-minded goal of winning a Grand Prix World Championship. However, it quickly becomes apparent that in order to fund his dreams, he'll need to sell cars to the public.
Enzo Ferrari would have told you that racing to him is everything, and the road-going cars were an afterthought, a necessary evil that he had to sell in order to finance his racing efforts.
Building cars was a side business that enabled his primary passion, which was racing.
Ferrari's first customer-badged cars debut in 1947. One of its key differentiators is a V12 engine.
Ferrari decided to make a V12 engine, and you had a little jewel. It was like a garnet on a velvet tray. This little impossibly complicated mechanical device that just sang because of its 12 cylinders.
In 1952, Ferrari debuts the 212 Spider.
What Ferrari did was something that nobody else did in the days. He took a V12 engine and put it in a body of jewel-like perfection.
The machine leads to the 250 series, the company's most successful early line of customer cars, which spawns multiple variants.
The whole lot just came together in a beautifully balanced, fast weapon. This thing was designed to win races, and boy, did it do so. And it influenced Ferrari production cars for several years to come.
Ferrari's early cars combined svelte packaging with powerful engines. and help crystallize the image of a sporty car. Yet perhaps their greatest contribution to the supercar genre isn't actually their tech, but rather the fact that they give Enzo Ferrari the runway to flourish.
During the late 40s and early 50s, Ferrari was it. They were really, really expensive. Ferrari's influence on supercars in the day was quite great.
As early Ferraris begin dominating road racing, in Germany, a man named Ferry Porsche aims to transform his father's engineering company into a legitimate automotive manufacturer with the introduction of the 356.
The name Porsche was synonymous with a strong engineering background. I would argue that when Ferry Porsche launched the 356, that's when you saw the Porsche that we know today.
The 356 is a radically different take on the sports car. At the time, most cars utilize a front engine design. However, the 356 features a tiny four-cylinder air-cooled engine sitting in the back of the machine, directly over the rear axle. While the 356 is a blast to drive, it isn't an immediate sensation. The idiosyncratic layout crystallizes the Porsche philosophy and will eventually lead to the iconic 911.
They've always been focused on two things, being fast and being fun. And that's a sort of core value that they've stuck to right from the word go.
While Enzo Ferrari builds his Italian empire and Ferry Porsche transforms his engineering firm, in England, an old stalwart reawakens and helps revitalize the sports car genre along the way.
The Jaguar builds beautiful cars.
In 1948, Jaguar returns to glory with the introduction of the XK120. It is one of the fastest cars of the period and helps bring the mark back into the sporting fold.
The XK120 in the early 50s that really put them on the map. This car was so named because it went 120 miles per hour on the Jacobi Highway in Belgium.
The XK120 layers aluminum over an ash wood frame, creating a very light front-engine roadster. Yet more importantly, it becomes the archetype of the English two-seat sports car, a genre that has profound effects on the supercar space in the coming decades.
It really was a defining car for Jaguar, and that was a stunning car, very successful car.
As road-going sports cars become easier to define, out on the track, Grand Prix racing takes the next evolutionary step with the introduction of Formula One in 1950. One mark immediately dominates the competition: Maserati.
Yeah, Maserati, in the 50s, basically built race cars. They built, some of the fastest cars in the world at the time.
If you close your eyes and think about a 1950s Grand Prix car, chances are you're thinking of a 250F.
Designed for the 2.5-liter F1 regulations, the 250F uses a simple tubular frame to carry the suspension, support the aluminum body panels, and hold the engine. The machine is campaigned over 6 Grand Prix seasons and is both the launching pad for Stirling Moss's racing career and the car that helps Juan Manuel Fangio take home his 5th and final driver's title.
Their cars in the 50s were successful in racing versus Ferrari by virtue of excellent handling. Their chassis design, their handling, their braking was very good.
Maserati was really Ferrari before it was Ferrari. I mean, they were building these just achingly beautiful race cars and road cars and competing at the top levels in Grand Prix.
The Maserati 250F is not only dominant on the track, but also within the industry. It represents one of the great front-engine F1 cars and the beginning of a new era when manufacturers begin thinking about their sports cars in a holistic and unified fashion.
The engine is aided by more powerful brakes or better suspension or a better chassis, but these are still individual components. What these components were lacking at this point was a vessel, a cohesive vessel for everything to go into. And that's what created a supercar.
By the tail end of the 1950s, society is booming, and auto engineers have found a bounce in their step. The machines they are about to create will radically reimagine motoring and pave the way for the supercar era. Supercars push the boundaries of both art and science, yet bringing them to life requires precision engineering and a bold ability to dream.
Part of what goes into a supercar is a lot of intellectual calisthenics, a lot of machinations, because you have to dream up this stuff.
Following the austerity of the post-war 1940s, the car industry explodes with creativity in the 50s.
You just have the visionaries, the people that were behind these incredible inventions that were so passionate and so driven to create these things in a world that largely told them they were crazy. And to continue to pursue it tirelessly at risk of life and limb in many cases is what has culminated in the era of the supercar.
One of the most innovative and drop-dead gorgeous sports cars arrives in 1954 when Mercedes-Benz introduces the 300 SL. It is a landmark machine that almost single-handedly rewrites the contemporary sports car overnight.
The 300 SL took all of the technology that Mercedes gained in racing and applied it to a very civilized road-going car.
The 300 SL Gullwing was Mercedes-Benz effort to try and re-establish themselves successfully as a premier sports car manufacturer.
Mercedes bases the machine on the marque's successful SLR race cars, which finish in first and second place at Le Mans just 2 years earlier.
Mercedes was always an engineering powerhouse. And in the mid-50s, Mercedes-Benz wanted to go racing, so they created the 300 SL, which is basically a race car. And then they adapted that technology for the street.
Even though the 300 SL is based on a race car, it's fundamentally designed for street use. This will become a key strand of the supercar's eventual DNA.
This was a highly advanced car for the mid-50s. It had a tube frame construction.
The 300 SL's lightweight chassis weighs just 49 kilos. It's so light that just one man can pick it up. The machine is so svelte that Mercedes decides to badge it as an SL, which stands for Superlicht, or super light.
Mercedes 300 SL had gullwing doors, and the reason it had gullwing doors was because of the monocoque chassis, or I should say frame.
The innovative space frame gives the 300 its required rigidity, yet it also creates a problem. Conventional doors won't work because the chassis sits above the occupant's cell, so engineers are forced to think outside of the box.
All these little tubes were welded together to get the kind of structure, to get the kind of solidity that Mercedes had to have, that they were known for. That structure had to come halfway up the side.
The sills had to be so thick because of the tube frame construction that they couldn't have conventional doors, so they hung gullwings on it, roof-hinged doors, which would open like a bird, and that's how it earned its nickname, the gullwing.
It's a classic case of form following function. The cutting-edge space frame actually necessitates the gullwing doors, which in turn help transform the machine into a style icon for the ages.
The doors themselves certainly attracted attention, like, wow, look at that.
The doors are practical, yet more importantly, they set the template for nearly all future ultra-exotic sports cars to follow.
Watching those doors open for the first time must have been like watching a Martian get out of a spacecraft.
Underneath those doors, an extremely capable car. Space frame chassis, swing axle, at the time sophisticated rear suspension. A very, very capable car for its period.
The 300 SL sets a new standard thanks in part to its 215 horsepower 3-liter straight six. It is the very first production sports car engine to feature fuel injection.
Revolutionary, the 3-liter engine was the first production car engine to use direct fuel injection, but the handling was a bit lively. That sort of added to the mythicism and kudos of the 300 SL Gullwing, a really great landmark car.
The Gullwing is definitely a milestone car of the 20th century. It's an iconic design. I mean, it was a supercar before anyone even thought about supercar as a thing.
The breakthrough fuel injection tech revolutionizes the car industry because it helps an engine run smoother and more efficiently.
With fuel injection, there's a predictable amount of fuel that is squirted through the cylinder each time, so it makes more consistent combustion, better fuel economy, better power, better reliability. It's just better all the way around.
Fuel plus air equals motion. That's the basic science behind all combustion engines. Early power plants use a device called a carburetor to help regulate the air and fuel mixture. However, it's hard to tune and rarely delivers the right amount of petrol when the engine needs it most. Fuel injection remarkably improves the situation. It precisely controls the flow of fuel to the engine, which not only is more efficient, but also guarantees a higher power output.
Let's give this car this crazy thing called fuel injection. That way you don't need a carburetor that decreases performance in turns because of the centrifugal force of gasoline in the fuel bowl of a carburetor.
Fuel injection comes on the scene thanks to racing, before Mercedes-Benz harnesses it for their road-going sports car. However, the differences between the track and the tech needed on a country back road are quickly diverging.
During the 1950s, the technology that was embodied in a racing car was fairly easily transferable to that of a road car. Before long, the differences became sharper and sharper.
As the automobile continues to evolve, race cars and road cars are heading down two different technological paths. Many believe that the true fork in the road comes in the late 50s, when British automaker Jaguar dominates Le Mans, winning the race in 1955, 1956, and again in 1957, with an impressive 1, 2, 3, 4, 6 sweep.
The D-type very easily represents the fork in the road, because here you had a car that was a racing king. It won Le Mans multiple times. You couldn't beat it.
The D-Type is a masterpiece of racing tech, yet it's quickly outpaced thanks to the continual march of progress.
Even though there was a time that it was considered unbeatable, that doesn't last forever. Pretty soon, other manufacturers, other engineers see what you're doing, and they embody those innovations in their own cars. Then you have to up your game. When Jaguar saw that its D-Type was no longer competitive, they say, okay, I get it. We still have a bunch of these left over. In fact, we had 25 left over, so why don't we make them into road-going cars? The ultimate road-going cars.
Sensing the shift, Jaguar Company founder Sir William Lyons decides to convert his unused D-Type race cars into menacing road cars. It is the birth of the Jaguar XKSS, one of the most beloved and voluptuous machines ever created.
It's considered to be one of the most beautiful cars in the world.
To transform the D-Type into a roadworthy vehicle, engineers cut a door in the machine's bodywork, axe the aerodynamic racing fin, and add a full-width windscreen.
Let's take the little windshields off and give it a proper windshield. Let's give it a proper top. Let's give it a means to carry luggage. So it's easy to see how one racing car can become a road car and how one path takes you down a completely different road, literally and figuratively.
The importance of the XKSS isn't how fast it goes, but rather how quickly it stops. It's one of the very first road-going machines to utilize disc brake technology.
You can have the most powerful engine in the world, but if you don't have the brakes or the chassis to handle that engine, it's going to go fast in a straight line and eventually slow down or crash into something.
Jaguar starts working on disc brake tech in the early 50s, and it becomes a cornerstone of the company's racing success.
A more powerful engine is stopped faster by disc brakes.
When a car is running at full speed, it holds a tremendous amount of kinetic energy. When you try to stop it, that energy has to be dissipated. On disc brakes, a caliper squeezes pads against a rotor mounted to the hub of the wheel. This creates friction, which slows the vehicle down and transforms the energy into heat.
In the early 60s, four-wheel disc brakes was like moonshot stuff, you know.
While the XKSS makes serious waves, as the 1960s dawn, it's another Jaguar sports car that shocks and awes the world, the E-Type.
The Jaguar E-Type was such a seminal car. It just looked like sex on wheels.
The E-Type was a game changer for a Jaguar.
Introduced in 1961, the E-Type foreshadows a decade of great progress for car design.
Probably the car that pops into most people's heads when they think about Jaguar. Even now, today, if you drive one, you're still impressed by how well it drives, how wonderful it is. You know, how smooth the power is, how it rides, how it handles.
When it's introduced, the E-Type becomes the world's fastest production car and hits a then unheard of 150 miles per hour.
I think it is a car that most people will agree is beautiful and such an expression of the 1960s and the era of liberalization and do it because it feels good, and no car represents that better.
The E-Type's striking beauty is due in part to the machine's aerodynamic look.
This design by Malcolm Sayer, where he laid out all the points of the design mathematically, the way you would design an aircraft, but yet produce this, you know, totally organic, visceral shape. It really was lightning in a bottle.
Up until about the time of the Jaguar, aerodynamics was more art than science. If it looked sleek, it was aerodynamic.
At the time, little is known about automotive aerodynamics, so Sayer tapes tufts of wool to prototypes and observes them while driving down the road.
Drag is the amount of force being applied to a car as it goes through the air. It's like the friction that the air has against a shape as the shape moves through it, and so less drag is better because it's more slippery aerodynamic.
As the science of super high performance comes into a sharper focus throughout the 60s, a group of brave mechanical masterminds in northern Italy ponder what comes next. The car they envision will change the game once and for all. Throughout the 1960s, sports car tech dramatically continues to evolve. Yet defining what makes a supercar is still completely unknown.
A supercar is a collection of some of the best technologies all in the same car.
Today's supercars are often judged by two technical factors: their 0 to 100 kph time and their top speed. Yet they're equally celebrated for their style and bold designs.
A real supercar is the driver supercar, a car able to create emotions, to create passion, to create driving pleasure.
One of the most glorious and stunning cars in the early 60s originates in England, yet it's launched to stardom thanks to Hollywood, the Aston Martin DB5.
The DB5 was a really, really great all-rounder. It had bags of performance, but it was a combination of style, the beautiful front end with those faired-in headlights, the really lovely interior with swathes of Connolly leather, the refined powertrain, the powerful engine.
DB5 is undoubtedly the most famous Aston Martin and probably one of the most famous cars in the world.
As fate would have it, the DB5 catapults Aston Martin to fame when it commands a leading role in the James Bond movie Goldfinger. Yet even with all the secret spy gadgets stripped away, the machine is still a stunner, thanks to gorgeous looks and masterful 140-mile-per-hour top speed, making the DB5 one of the world's fastest cars at the time.
It took us into the motorway age in Europe, and it was a very luxurious and fast grand touring car. 140 miles an hour top speed.
Our sports cars at that time had a very, very classic feel.
The DB5's classic driving feel is helped by the use of a 5-speed synchromesh gearbox, which allows a driver to change gears without needing to match the speed of the engine to the rest of the drivetrain.
Up there with the Ferraris and Lamborghinis, very, very high-performance car of its day.
There are era-defining cars, and then there are transcendent machines. The 1963 Porsche 911 is both.
The 911 is one of the longest running names in the sports car scene. The brand would not exist if it weren't for this car.
To drive a Porsche, there is a oneness with the car, a solidity with the car that you just don't find in any other manufacturer.
In the early 60s, Porsche is a small car constructor fighting to survive. Company engineers decide to stake their claim to the sports car market and debut a new sporting machine.
The 911 is such a good quality, practical car that does magnificent things on the road that other impractical and unreliable cars might sometimes do, that developed a niche for Porsche that they really own. They are it.
The niche that Porsche cultivates stems from their unorthodox decision to use a rear engine layout.
It's an enigma because the 911 is a continuous improvement of a car that doesn't make sense.
Placing the engine in the rear creates a physics problem. When the 911 enters a corner, the majority of its mass wants to continue moving straight ahead, even as the car begins to turn.
Why hang the engine out in the back? It's a pendulum out there. It's fighting you all the time.
While the 911's layout fights convention and physics itself, it also inspires drivers by offering a very distinct sporting style.
If you drive a modern 911 and then you drive a 60s 911, you can see the lineage between them.
By the middle of the 60s, the technical elements are finally in place for the greatest transformation of the automobile since its inception. And surprisingly, it doesn't come from a corporate behemoth, but rather a small rural Italian car constructor that's only been in business for 3 years. In 1966, Lamborghini reinvents the sports car when it debuts the Miura.
The paradigm shift came with the introduction of the Lamborghini Miura.
The Miura, which just kind of like kicked off the supercar race.
And they produced this car, and the course of automotive history changes.
The Miura is both stunning and groundbreaking. It's luxurious, fast, cutting edge, and highly exotic. And more importantly, it's the very first machine to be called a supercar.
The modern supercar sort of begins with the Lamborghini Miura.
The expression supercar was, I believe, coined by a British journalist describing the Miura, and it almost certainly was the first supercar.
The Miura launches to massive acclaim and immediately sparks the imagination, thanks to its massive transversely mounted quad-cam V12 engine that produces a whopping 350 horsepower.
This was a car that used the V12 that Ferruccio Lamborghini had developed. Instead of turning it longitudinally, he turned it transversely, put it in the middle of the car, behind the passengers, but in front of the driving axle.
While the orientation of the engine is unique, it's actually where it sits in the chassis that makes the machine so special. The Miura is the world's first production supercar to feature a mid-engine two-seat layout.
The thing that's really special about the Miura from a technological point of view is that they took this great big 4-litre, 4-camshaft V12 engine and shoehorned it into a tiny space across the car transversely. And they actually found room to put the gearbox in with the engine in one casting, as it happens. That was way out there. There's hardly been a car made before or since with that level of engineering audacity in it.
The Miura's technical layout redefines the game and opens up the floodgates for all future supercars.
You've got a car that looks like it's doing 150 miles an hour standing still, really fabulous shape. It makes the most wonderful noise, and it's very, very powerful and very fast.
The stunning success of the Miura immediately proves the validity of mid-engine machines.
Lamborghini invented the mid-engine supercar, and the reason that all supercars have followed that formula is because it's the right one.
What the Lamborghini Miura did was set a new standard. It was essentially an engineer's epiphany. They said, we didn't have to make front engine anymore. Let's put the engine really where it belongs in a car.
They just started moving stuff around on the table, and they came to this notion of putting the engine and transmission parallel together in the car sideways.
Let's throw away the rule book. Let's start with a clean sheet of paper. Let's do it the way we've always wanted to from the beginning.
The clean sheet design allows engineers to focus on the best technical solutions and not conventional wisdom. To build an exceptionally brilliant handling car, they decide to centralize the mass in the center of the machine.
With the engine in the middle of the car, you have the right ingredients right off the bat for great handling.
In addition to better handling, a mid-engine car offers numerous other performance advantages, including increased stability, a more comfortable ride, and perhaps most important of all, improved traction. Placing the heaviest object in the center of the vehicle gives each tire maximum grip, which when combined with a high horsepower engine is a recipe for fast acceleration.
Mid-engine cars, where the engine's in the back, have a lot more weight in the back, and that helps them put that power down.
Ultimately, the Miura stands out as a massive turning point that sets the template for what a supercar is, while also altering the destiny of high-performance sporting machines in one fell swoop. Yet it's not the end of our story of speed, but rather the launching pad for the next great generation of designers and engineers who will push the boundaries even further. The Miura's perfect blend of Italian flair and pioneering high-tech science renders all other previous sports cars obsolete. Now, there's a need to push further and faster.
To call a car a supercar is to call it a superlative. It's like a supercomputer, a supermodel, a supervolcano. These are things that are way out of the ordinary. They're so extreme that they deserve special attention.
As the auto industry enters the 1970s, the quest to create the perfect supercar kicks into a higher and more ultra-modern gear. Futuristic design takes center stage, especially when paired with a V12 engine and a super low-profile shape.
The early wedge shape, really flat surfaces, really low, wide.
The wedge supercars, it's like the wedge shape is the best for aerodynamics.
The introduction of the mid-engine layout and the functional look of cutting-edge aircraft inspire Italy's car designers to ditch the sensual and rounded look of post-war sports cars. In its place, they craft an entirely new design language that's based on the best aerodynamics of the day and aimed at redefining what's cool.
You put a giant V12 engine in something that looks like anything from the Lamborghini portfolio or a Ferrari, and people will sit up and take notice. And a big part of the supercar sort of ambiance is the design. It has to be different from something that we've seen before.
The wedge era's magnum opus arrives in 1974, and it's called the Countach.
The Countach kind of ushered a more modern era.
Really, the only successful response to the Miura was its replacement, the Countach, that was even more outrageous.
Honestly, the Countach pops to mind because of the just crazy design.
Overnight, the Lamborghini Countach makes all other high-performance machines look ancient. It's a complete departure from traditional machines, and a landmark supercar.
If you see a Countach coming at you down the road, it doesn't really register what it is. It doesn't really register as a car initially. You're like, what planet did this thing come from? And then it comes up on you and you're like, crap, that's a Countach. It still does that.
It's something that looks like it's ripped from the pages of a comic book. And prior to that, I hadn't seen anything that was like that.
That really, to me, was the beginning of the supercar. The longitudinal V12, the scissor doors, that was the benchmark that still exists today.
While the Countach is never properly raced, it employs outrageous visual elements that harness the era's obsession with futurism and then backs it up with outrageous high performance.
They placed the engine lengthwise in the car to make more room for transmission to be placed properly to help with weight distribution.
With the transmission running up between the seats so that the gear shift would go directly into the transmission, it would be a very precise, solid feeling, though heavy, transmission.
The Countach is magical on the road, yet it's the machine's ultra-wide and low proportions, knife-edged flat body and scissor doors that set the agenda for all subsequent Lamborghini sports cars and helps the vehicle become a poster child for the supercar genre.
There's something about Lamborghini and the design that they create that makes it just so outrageous. It's like they designed spaceships. They aren't afraid to test the limits and push bounds.
The Countach was really the only effective replacement for the Miura, and it was so effective that it created a genre all of its own, which was the supercar. It didn't exist.
While Lamborghini pushes the wedge concept on the road, their Italian neighbors leverage the same design aesthetic in rally car racing.
Lancia's big thing was bringing racing technology to production cars and even pushing the boundaries on racing technology sometimes too.
In 1973, Lancia introduces the Stratos. It's the first series-produced car built from scratch to compete in the World Rally Racing Championship.
What I love about the Stratos is that it's engineering first. It's a car with all of these firsts, and it's designed with racing in mind. In fact, that's exactly why the car was built, was to go racing. And the shape, well, it was different.
The Stratos signals the beginning of a new era, where car manufacturers sell small batches of thinly disguised race cars to the public in order to qualify them for specific racing series.
The Lancia Stratos is another key point in the development of supercars because it went from gently curved and voluptuous to angular and a little bit more severe. And that's because aerodynamics were becoming more and more important to vehicles.
The Stratos is quite the bit of kit. Lancia sources a 2.4-liter V6 from none other than Ferrari and then mounts it in the middle of the chassis.
The Lancia Stratos had a Dino/Ferrari V6 mounted in the middle, transversely mounted V6 with a ton of power, high revving, built to race.
Lancia builds just 500 examples, and every single one exists just so the company can go racing.
Even for rally cars like the Stratos, you still had to get across a desert pretty fast, and you were still going to need a car with a little bit of aerodynamic advantage to do that. This is what Lancia did, and it kind of pushed the passenger compartment farther forward and farther forward. When you think about it, just like almost everything else, the supercars were inching their way towards that design feature from the very beginning.
The powerful engine, lightweight short wheelbase, and twitchy handling help make it a hugely successful machine. The Stratos wins the World Rally Championship 3 years in a row, from 1974 to 1976.
This car also had the Italian driving position, which I also call the water ski position, which is your arms are straight out and your knees are bent up and you're blocking your diaphragm, and you understand why Italians are so pissed off when they're driving, because they can't breathe.
The Stratos ushers in another evolutionary step in the supercar story. Yet it's also a prime example of the increasing engineering interest in harnessing the power of the wind.
The aerodynamic revolution happened in the late 60s, early 70s, where wings started to go onto cars to create downforce, to push the cars down into the road, to give them better grip.
Downforce is similar to the principle of lift that helps airplanes take off, only it's turned upside down. Instead of pushing an object upward, downforce pushes it into the ground.
Downforce is the amount of force that the air puts on a part of a car as it moves over it. So everyone thinks that a big spoiler on the back of the car is to make it go fast, and that's true. The faster you drive with the car, it inherently becomes less stable, and downforce puts more weight on parts of the car to make it more stable at higher speeds.
The Lancia Stratos has a small evolutionary spoiler. However, the cars that follow it will push the tech to outrageous heights.
Cars with giant wings go faster, not because they have more power, it's because they make more downforce.
All the car manufacturers realized, let's do a full aerodynamic package so that the car presses down at speed and we can have higher cornering speeds.
A prime example of how aerodynamics and the need for greater downforce quickly influence car design comes from Germany just a year later. In 1974, Porsche introduces the 911 Turbo.
There were a number of cars that came out in the 70s as a response to the Miura, and the 911 Turbo is an example.
The 911 Turbo was shown in 1974, and Porsche had been using turbochargers in its race cars. This was their first production car with a turbocharger.
The 911 Turbo represents a pragmatic take on stratospheric high performance. It pioneers forced induction in a battle-tested platform that can attack a racetrack, as well as take a grand tour across the continent.
Because of its propensity to suddenly violently oversteer or throw itself off the road, it was known as the Widowmaker. That was one of the nicknames. Could be a very dangerous car in the wrong hands.
The initial 911 Turbo is known as the 930 inside of Porsche, and the machine's turbocharger adds 0.8 of a bar of boost pressure, which helps the flat six engine produce 260 horsepower.
Most people think that the original 911 Turbo was meant as this kind of sideways bad boy car. It wasn't. It was meant exactly the way the 911 Turbo is today. It was meant to be a luxury version of the 911.
People really revere the 930 because it's very rewarding to drive.
The Turbo is rewarding to drive, in part because it utilizes a huge rear wing that comes to be known as the whale tail. It isn't there by accident. Engineers determine that the machine needs it in order to generate enough downforce to be stable at top speed.
One of the quickest cars on the road at the time, and for a long time, the quickest car on the road.
The 930 isn't the first sports car to use a turbocharger, but it's perhaps the most iconic. During the 70s, turbocharging tech is avant-garde. Yet today, it's fairly commonplace, and everything from supercars to economy vehicles leverage its ability to get more horsepower out of a smaller engine.
It was early days. It was a bit like an on-off switch. You're either on boost or off boost, and when the car was on boost, the power was double. It was vicious.
Like a supercharger, a turbocharger provides the engine with more oxygen. However, instead of being powered by the engine, the turbines are driven by exhaust gases instead. The brilliance of the design is that it capitalizes on free energy that otherwise would be lost. The downside is that a turbocharger often takes a while to spool up, a situation known as lag.
Until it got a lot of spin, it didn't do much. Modern-day turbocars have smaller turbochargers that respond more instantly and produce a more linear power surge.
Once reserved only for ultra-fast machines, turbocharging has now trickled down to a wide range of different types of vehicles, thanks to their ability to make more power from less petrol.
The difference between cars from 1965 to 1980, where you go from carburetors and no emissions controls and no electronics to now electronics, fuel injection, catalytic converters, just in 15 years. That's really defined the automotive age in the latter half of its century.
From the earliest automobiles until now, supercars have seen a rapid progression and an incredible advancement. Yet the dawn of the next decade will offer an entirely new set of groundbreaking machines. Vehicles that amplify the primal rush that comes from speed, push the boundaries of our imagination, and ultimately take the supercar to intoxicating and unthinkable new heights. Supercars. They're furiously fast, chock full of the latest technical advancements, and amazing marvels that live on the absolute razor's edge of engineering.
The story of supercars is humanity's movement at speed.
A supercar can be both a reflection of egos at work and also as a test bed for technology that will eventually find its way into more mainstream cars.
With eye-watering specs, cutting-edge tech, exotic designs, and blistering performance, supercars represent the very best of the automobile. And an advanced test bed for pioneering solutions.
In the old days, and by the old days I mean 10 years ago or further, supercars were an attempt to express the current advanced state of engineering.
The supercar echelon is populated by visionaries. So people that are really passionate about whatever aspect of the machinery, that whether it's engines, whether it's physical design, whether it's winning races. Generally, those are the three tenets that drive supercar creation.
This is the story of mankind's relentless pursuit for speed, the remarkable machines that brave the way, and the amazing evolution of supercar tech. At the dawn of the 1980s, global wealth is rapidly expanding. Ordinary cars are now more accessible than ever before. A booming stock market and rocketing economy help mint an entirely new strata of buyers and launch the supercar genre to stratospheric new heights.
A supercar is unattainable, it's magical, it's this weird and fantastical thing that goes ridiculous speeds and looks absolutely otherworldly. How do you not celebrate that?
During the decade of excess, ridiculous looks and out-of-this-world performance collide to create a series of fresh and inspiring machines. However, it's the advent of computerized tech and a new variant of homologated racing that thrusts the machines to their limit.
Really, the development of computerized cars driven by the need to homologate cars for racing. That's what produced the 959 and the 288 GTO and the subsequent F40.
The 80s are a decade of audacious dreams that sees the supercar morph from a merely advanced machine into a flat-out technical wonderkind. It takes a unique vision and quite a bit of passion to bring them to life.
So without that passion, nobody's going to spend that kind of money to just create the engineering and the sheer design will that it takes to craft something that unique.
The 80s proved to be an extremely productive and groundbreaking period of supercar science. And no machine sets the stage quite as profoundly as the humble 1980 Audi Quattro. It's not a supercar, but its tech is crucial for the genre's evolution.
When we introduced the Audi Quattro at the Geneva Auto Fair in March 1980, this was a car nobody had ever expected from Audi.
They introduced an all-wheel drive car way before everybody else.
When the Quattro breaks cover, it changes everything. The machine's four-wheel drive system revolutionizes rally car racing.
Audi made a name for itself because its claim to fame was Quattro.
During the decade, Audi wins 4 world titles for one very simple reason. Their cars can get more power to the ground than anyone else's.
The Audi Quattro was a combination of this turbo engine with a four-wheel drive, a permanent positive four-wheel drive.
Remarkably, the Quattro system is born thanks to a humble Volkswagen off-roader. In the winter of 1976, Audi engineers are cold weather testing in Sweden when they see a VW Iltis conquering everything in its path. The humble off-road vehicle is powered by a meager 75 horsepower engine, yet its all-wheel drive system allows it to run circles around Audi's newest machines. Seeing the all-terrain machine succeed where their vehicles fail gives engineers an idea. They decide to harness the all-wheel tech, upgrade it with a hollow secondary shaft, which allows power to go 2 directions inside the transmission, and put it into their own road-going car. Then, to demonstrate the benefits, Audi decides to go rally car racing, and a legend is born.
In the 1980s, the Audi Quattro race car, the Quattro, came in and absolutely destroyed rally racing. It completely changed the game with its all-wheel drive system.
The four-wheel drive machine quickly revolutionizes rally car racing.
There's all these two-wheel drive cars, and then the Quattro came along with its four-wheel drive and just obliterated everything in sight.
All-wheel drive and four-wheel drive sound similar, but they're actually different bits of tech. Four-wheel drive is a part-time system that sends equal power to each wheel, and it's typically intended for off-road use. The brilliance of the Audi Quattro's all-wheel drive system is that it's always on and optimized for the road. A computer seamlessly determines which of the 4 wheels need power and traction.
Audi magic has really come down to design and technology.
All-wheel drive, of course, means that all 4 wheels turn. You can implement that all-wheel drive in very different ways. And
Quattro is one of the first broadly available all-wheel drive systems. It uses this cool, like, front-to-back and side-to-side technology where it's this always-on all-wheel drive system.
The Quattro is the first production car to combine permanent all-wheel drive with a turbocharged engine.
And Audi was the first company to design a gearbox with an integrated differential for the differences between front and rear axle when you go on corners.
They are just phenomenal cars in terms of handling and road holding. And with that turbo 5-cylinder engine, bags of fun as well.
The Quattro system is a harbinger for what will come next. Its introduction is massively important for all future supercars because the basic philosophy is the key to transferring mega-high horsepower engine output to the ground.
Audi showed people that all-wheel drive is awesome for performance.
The car had a large influence on Audi because today we are over 60% of four-wheel driven cars and in the production figures. And it had an influence on the complete automotive industry because, like today with electric drive, every company started building 4x4s. While
Audi radically revolutionizes power delivery, Their longtime German rival BMW attempts to change their image thanks to an inspired new machine called the M1.
The M1 is a first in many aspects for the BMW brand. It was the first supercar for BMW.
The M1 was sort of a showcase of all the technology and engineering that BMW had in the late 70s, early 80s.
The M1 is BMW's first mid-engine sports car and features a 273 horsepower, 3.5-liter six-cylinder motor that powers the machine to a 260 km/h top speed.
It had BMW's most powerful engine in it at the time.
That glorious double overhead cam, straight six engine, really, really successful car.
The performance wouldn't seem that, earth-shattering today. At the time, it really was.
BMW originates the M1 as an expression of automotive art. The M badge designates the brand's most meaningful engineering projects, and the 1 signifies its importance. The vehicle's body is an aerodynamically efficient envelope wrapped around some serious velocity-generating hardware, yet only 430 examples are ever made.
They drive really well. I was shocked the first time I drove a BMW M1. Yeah, very capable car.
It sort of set the high water mark for BMW in the early 80s and sort of elevated the brand from a brand of just sedans into a brand that could perhaps build a supercar.
Across the English Channel, an entirely different take on the supercar is being explored. Inside the halls of Aston Martin, engineers conceive of a new machine called the V8 Vantage.
So you have your sort of standard Aston Martin, if anything can ever be called that from their production run. And the Vantage has always been the creme de la creme.
At the time of its introduction, the V8 Vantage is the fastest road-going Aston ever produced.
The original Vantage absolutely was a beast.
The 375 horsepower engine helps the machine blaze a new trail for the storied English automaker. It hits a healthy 170 mph top speed.
Whenever anybody says Aston Martin Vantage, you know immediately it's going to be something really, really super special.
Being special is a crucial element of supercar DNA. A machine has to have a hefty price, be utterly rare, feature out-of-this-world design, and of course, showcase epic performance.
If you've ever been in a very fast vehicle, there's something that happens to you physically that is hard to describe to someone who's never had that experience. It is a visceral, almost lizard brain kind of experience. It's almost like an adrenaline hit. There's a sort of addictiveness to it. Once you've had that little taste, it's easy enough to understand how people just want to go faster and faster to the limits of human capacity.
Chasing high performance at the very limit is an addictive drug that car constructors have pursued since the dawn of the automobile itself. Yet by the mid-1980s, there's one mark that's about to rewrite the rules of speed and forever alter the supercar landscape. And it's called Ferrari. They combine speed, handling, and unique design, while also representing the pinnacle of automotive art, the supercar.
In the supercar space, being different is part of the elemental key that makes it a supercar.
Throughout the 80s, as car tech evolves, enthusiasts increasingly debate what constitutes a supercar.
Identifying a supercar is interesting because some of the very compromises that you make to extract the best performance create the outrageous styling. It's kind of out of necessity that the car looks like that.
While classifying a supercar is often subjective, their technical prowess is awe-inspiring and undeniable. During the decade, one brand in particular takes the lead, introducing a trifecta of machines that will alter our perception of speed. Ferrari.
Ferrari is everything that a kid thinks a sports car should be.
Ferrari is synonymous with racing because that's really where they got their start.
Ferrari first finds fame in racing. Yet by the 1980s, their road-going cars are every bit as good and lustworthy as their Formula One machines. In 1984, they debut a masterpiece of tech, the 288 GTO.
The 288 GTO was the answer to a question raised by racing. It was meant to be a homologated version of the Ferrari 308 for Group B competition. The problem was that by the time the car got produced, Group B had been ended because it proved to be so deadly and was killing drivers left and right.
The end of Group B racing results in one of the greatest supercars of all time. The GTO, that stands for Gran Turismo Omologato, and offers drivers massive firepower under the hood that's wrapped in a scintillating bit of bodywork.
It took everything that Ferrari had from a technical standpoint to produce the car. They were technological moonshots.
Fast, beautiful, and charismatic, the 288 is built with little concern for time or money.
It really harnessed everything that Ferrari knew about making horsepower, turbocharged horsepower specifically.
The 288, when the turbos kicked in, hang on, it's gone.
The GTO's magic ingredient is the combination of 400 brake horsepower keyed to a 1,200 kilo curb weight.
It was you and the machine and the road, and that was it. You didn't get a lot of help. For that reason, it was a very rewarding car to drive, because not only could you show off the capability of the car, you could show off your capability as a driver.
The 288 is a homologated special built for a series that never exists. Yet its importance can't be overstated. The machine marks a transcendent turning point for Ferrari and the beginning of the marque's quest to create small-batch, range-topping mega machines.
The problem is that the war ended before they showed up. Instead, they sold their homologation cars to customers, and it's come to be recognized as this icon of a certain moment in time when turbocharging was just coming onto the scene, and you had these hugely powerful cars being raced on the road for the last time.
While the 288 GTO never fulfills its promise as a race car due to the Group B series demise, it does stand as a testament to Ferrari's grasp of cutting-edge tech at the time.
When Group B ended, that was really the end of almost unlimited speed and horsepower for road racing.
While the 288 represents Ferrari's high-performance zenith at the time, it's not the only mouth-watering supercar to come from Maranello during the decade. In 1984, they debuted the Testarossa.
So they came out with the Testarossa. It exemplifies that era better than anything else.
The Ferrari Testarossa from the 80s is a very dramatic car from a styling standpoint.
The Testarossa is perhaps the most defining automotive contribution to the cultural collage of the 80s. It's all about image and is the poster car for a generation, which helps it become the best-selling V12 Ferrari by a wide margin.
It really broke the mold with the side strikes, the wide haunches, a very dramatic car that just says Ferrari. It says the ultimate in high performance.
Adored for its dramatic width and introducing side-mounted radiators with visible strakes, Ferrari truly ups its game with the Testarossa.
That gigantic front, that flat hood, and those slits on the side to see it going by you, and that incredibly wide rear end. Said boxer engine all the way. This engine is so big. We need to make the car that wide just so we can fit it in there.
The machine utilizes electronic fuel injection and 4-valve cylinder heads that help liberate 385 horsepower.
What's interesting about supercars is that, I would say beginning with the Ferrari Testarossa, they started to get bigger. And that's because the difference between a supercar and a race car was becoming more pronounced. When they were paying the kind of money that you were paying for a Testarossa, they didn't want a little car. No longer was a Ferrari the little scalpel that it was in the 50s. By the 1980s, Ferrari had become a machete.
By the mid-80s, Ferrari is firing on all cylinders and producing landmark machines. However, in the supercar space, it doesn't take long for the hunter to become the hunted. Supercars are an amazing combination of heady engineering, hardcore science, and nearly mythical high-performance art. Yet by the mid-1980s, the truly hallowed examples all seem to be coming from Italy. However, just a few countries north, engineers are about to deploy a transcendent machine that will up the ante once more.
Germans are focused and very disciplined in the work they do. And when it comes to engineering, those are advantages.
After watching Italy dominate the early part of the decade, German engineers decide it's time to fight back.
They also have a function over form philosophy. Their cars might go toe-to-toe with Lamborghini, but they're not going to have crazy wings or an unusable interior.
The Germans put more of a focus on good driving dynamics. We're going to make it just this like tight, precise, really nicely engineered car that's great at high speeds on an Autobahn, but it's also super fun when you're throwing it around on a back road.
The Porsche 959 breaks all the supercar rules. When it's introduced, it sits at the forefront of high-performance technology. More importantly, it's the first supercar of the computer age.
When the 959 came out, it just kind of rocked the world because it was unlike anything Porsche had done before.
Porsche's supercar transforms the venerable 911 into a four-wheel drive pioneer that tosses out convention and, in its wake, uses every technical advancement available in a single superb machine.
By the 80s, Porsche was a few decades old. They had come into their own, they had become respected, and not only had they been able to attract customers, they had been able to attract the best engineering talent. And they certainly put that engineering talent to work on the 959. It's a car that embodied every possible mechanical innovation.
The 959 is an Autobahn stormer and an engineering tour de force that's 100% emblematic of the decade's push for the best of everything. Yet it's born for the exact same reason that Ferrari creates the 288 GTO, to go Group B racing. And just like Ferrari, when the series is canceled, the marque has to pivot to recoup their investment.
Porsche wanted to go racing in Group B rallying, which was the highest echelon of rallying at the time, fastest rally cars. And so they developed this four-wheel drive, ostensibly 911-based supercar to go rally racing.
Porsche did it because they had the engineering capability at their fingertips. They had all this practice. They had people who said, you know what? We're pretty proud of this. You know, we've got a name to uphold, so let's uphold it. The world will know we made something very special.
Remarkably, the 959 uses 7 onboard computers at a time when most cars have 0. It also harnesses the power of its twin turbos to crank out 450 horsepower on its way to a 197 mile/hour top speed.
The 959 is everything Porsche thought would be relevant for the next 20 years. And it turned out to be kind of true. All-wheel drive, twin-turbo engine, over 400 horsepower, active suspension. Everything on the car was what was going to come in the next decade, what was going to come in the next 20 years. And, you know, all of that happened.
It wasn't a fragile, temperamental machine. It was a well-developed supercar that was packed with technology that was revolutionary for its time.
It introduced all this technology that we sort of take for granted, but at the time, putting it all in one place was kind of an amazing thing.
The machine's research and development costs are so exorbitant that it's believed that Porsche actually loses 200,000 pounds on every model it sells.
Everything on the 959 was way ahead of its time, 10 to 20 years ahead of its time. I mean, you had tire pressure monitoring, you had hollow spoke wheels, 2 turbochargers on a small flat 6, over 400 horsepower, all-wheel drive, 6-speed transmission, active dampers. Everything on the car is things we take for granted today, but in the mid-'80s, you know, this was from another planet.
The 959 is armed with computer-controlled suspension with adjustable ride height, run-flat tires with an air pressure monitoring system, anti-lock brakes, and magnesium wheels.
They said, you know what? We're going to embody every possible mechanical innovation we can think of, and we're going to do it right, and we're going to do it out of the gate, and it's still going to be a Porsche.
The Germans decide to enter the supercar race from a decidedly different philosophical point of view. Instead of building race cars for the road, they aim to create fast but comfortable everyday driving machines.
In the 70s, you know, computers were used to some degree, but not like they were in the 80s and 90s. And that allowed engineers to build things faster, better, and to a higher standard. And so development shrunk. They could do more in less time. And that sort of gave birth to all these incredible modern supercars.
Good supercars stand the test of time. Great ones predict the future so accurately that their excess eventually ceases to seem excessive. When the Porsche 959 launches, it seems utterly exotic. Yet decades later, its tech is now commonplace in ordinary cars.
You have the addition of sort of the technology aspect. The idea that computers can make faster decisions than we can. They can sense the road better. They can make quicker, minor changes to torque and apply brakes in a way that human capability cannot.
The 959's level of computerized sophistication is unmatched. Much of its tech will ultimately trickle down to ordinary automobiles.
A lot of technology that was pioneered in a supercar is now under the hood of just the most mainstream sedan today.
That innovation at that high end that does eventually make its way down into the cars that you and I drive.
I think the credit for the fast development and the incredible leap in supercar technology came from computers.
Ultimately, the 959 uses technology to allow any driver to get in and manipulate the machine comfortably at high speed. A remarkable combination of speed and civility. Yet for all its glory, there's still one magical milestone left unbroken. The 200 miles per hour barrier. Supercars are unimaginably fast, incredibly stunning to look at, and a unique bit of kit that merges both form and function into one sporty machine.
You know, a sports car, classically a sports car was a toy. It was something you drove just to have fun. It was something that existed just to be exciting.
What originally starts as a plaything for the rich at the dawn of the automotive age transforms into a cutting-edge, high-performance testbed by the late 1980s.
There is a trickle-down effect because they can prove out new approaches, new technology that could maybe later be applied to real-world cars, you might say.
Engineers across the globe begin applying new ideas and emerging tech to the advancement of the supercar. Yet one major milestone remains unbroken. The quest to see who can crack the 200 mile per hour barrier first.
I mean, 200 miles an hour is not slow, and it takes a lot of work to get a car to hit 200 miles an hour.
As far as automotive technology is coming, as fast as modern cars are, breaking 200 miles an hour is still a big deal. There's not very many cars in the world that can do that.
200 miles per hour sounds easy to achieve, yet hitting it is actually incredibly difficult to do. Because at those rarefied speeds, drag increases exponentially.
Wind resistance exponentially increases the faster you go. It's like the Richter scale for earthquakes. A 6 is way more violent than a 4. Same thing, there's the laws of physics. With a car, you need more and more and more power for each mile per hour increment, and to get to 200 takes a lot of power.
Nearing the double-ton power-weight ratios mean next to nothing. It's all about aerodynamics and horsepower. In order to hit 200 miles per hour velocity, engineers must find 8 times the power needed to hit 100 miles per hour.
You can do 150 to 180 pretty easily. You don't have to make too many modifications to do something like that, but once you get above 200, it's harder and harder and harder. The gap between each mile an hour you can actually hit gets bigger and bigger and bigger.
For decades, cracking the mythical 200 mile per hour barrier in a road racing car is thought to be next to impossible. Yet after Porsche throws the gauntlet down with the 959, Ferrari decides to push the supercar genre to new heights.
The F40 really upped the ante in terms of performance, brought turbocharging to the forefront.
The Ferrari F40 was the final manifestation of Enzo Ferrari's vision of a car.
No machine encapsulates the decade of decadence better than the Ferrari F40. The stripped-down celebration of all things Maranello is a seminal machine that becomes known as the ideal raw supercar.
The Ferrari F40 was this technological tour de force. Twin turbo, 2.9 liter V8, over 400 horsepower, which was, a ton at the time. It has a Kevlar and carbon fiber body years before people were thinking about doing that.
It's this icon of what Ferrari can do. Here's everything that we can do in terms of engineering, and here is this supercar at a time when supercars aren't really a thing.
While Porsche's 959 rival is a completely computer-driven tour de force, the F40 approaches the problem from the diametrically opposite end of the spectrum.
The Ferrari F40, it was completely different looking than any other Ferrari. It was built to celebrate Enzo Ferrari's 40th year in business. And what better way to do it?
He decreed that this car should be made as close to pure racing on the street as possible. It had no driver aids, no traction control, and the driver had to manage this car completely.
The F40 was the last car designed under Enzo Ferrari's personal guidance, and it betrays everything that made a Ferrari, everything that he wanted to imbue in a Ferrari, everything that he wanted a Ferrari to be.
Developed from the outset to be driven fast and to take back the supercar crown, the F40 becomes one of the decade's most significant machines when it does the unthinkable and cracks the 200 mile per hour barrier.
The F40 is the first car that brings racing technology to the road in a direct, visceral sense that anybody can see. It's unmistakable.
That racing heritage helps the Ferrari F40 become the definitive poster car for the era. Yet it's the machine's engine mounted in the middle of the car that becomes evocative. The 2.9-liter twin-turbocharged V8 produces 471 horsepower.
The F40 was a moment in time when turbocharging was relatively new. It was being used in Formula One. People thought it was the future of the internal combustion engine. And so to a certain extent, it represented Ferrari's statement about what the future of speed would look like.
Originally, Ferrari intends to build just 400 examples. However, clients clamor for more, and ultimately the factory relents, producing just over 1,300 machines.
All of that technology was suddenly available in a road-going car, a very limited production road-going car. And that limited production helped it to achieve supercar status. Part of being a supercar is not just looking better or performing better, it was being more exclusive. And Ferrari F40 certainly did that. And right out of the gate,
engineers are obsessed with keeping the F40 light. They use every trick in their arsenal, ranging from state-of-the-art materials to limiting the amount of paint used on the car. Yet it's the lack of driver aids that truly shaves weight and helps make the F40 such a celebrated machine.
that car in the right hands was every bit a race car that a Ferrari had been 10 years ago.
An analog car, not a computer-driven car. It depended upon the driver. The driver was the computer.
It was a fire-breathing, hard-running, fast, fierce car, just like Enzo Ferrari was personally. He was a lion, and his car was the automotive equivalent of what he was.
The F40 sees extensive use of carbon fiber and Kevlar to shave away mass. The chassis is a steel tubular frame that offers immense rigidity whilst being extremely lightweight. And more importantly, the F40 is one of the very first supercars to employ a fully carbon fiber body shell.
Most historians think, and I tend to agree, that the Ferrari F40 was a complete departure from other Ferraris leading up to it. It was a car that was brutally fast.
The F40, I think, is the ultimate development of the unassisted car. The driver has to do everything. The car will do nothing for you. Following that, other things came into play, particularly traction control and selective braking and so forth, things that will assist the driver. You can drive a new supercar very aggressively and not get in trouble. They will manage the driver. The F40, the driver did all the managing. It was totally up to the driver.
The F40 is ferociously fast and reaffirms Ferrari's grip on the supercar space. Yet the decision to build it comes down to just one man, company founder Enzo Ferrari.
The thing about these visionaries is that they had something in their personalities that allowed them to look at the masses and say, I'm gonna play a different game. I'm gonna go and do something else. They start with a seed of an idea that there's a better way to get there. There's a better, faster, more efficient, more creative, more beautiful way to get from point A to point B. And I think that's what makes some of these stories so interesting.
Smarting because the Porsche 959 garners so much acclaim, Enzo is determined to build an even better flagship machine. The resulting mid-engine rear-drive road racer achieves its astonishing performance through the time-honored combination of a hefty dose of horsepower and minimal weight, helping to make the machine one of the most hallowed supercars of all time.
The F40 represents that era of really fewer rules, more creative thinking, fewer boundaries, and it's a wonderful statement about that period, and it's why they're so valuable today.
It's a very significant car for that very reason. It's the ultimate manifestation of a driver-centric performance car.
While the Ferrari F40 becomes the standard bearer for high-performance machines, it doesn't hold the top spot for outright speed for very long. Just a few years later, a small boutique auto tuner introduces their very first serialized production machine, the Ruf Porsche CTR.
Ruf was an engineering company. They would take Porsches and re-engineer them. And nothing was sacred. Do the suspension, do the interior, shave off the weight, give it the most powerful engine, turbocharge it. In essence, Ruf was saying, Porsche, if you're not going to do it, we're going to do it.
Ruf reimagines the Porsche 911 Carrera 3.2 and equips it with a hopped-up twin-turbo engine, upgraded suspension, lighter body materials, and a custom 5-speed transmission.
Ruf was like the modern-day version of the backyard hot rodder in the early 50s and 60s. They were taking these aftermarket components, mixing and matching them to get just the right balance of acceleration and handling and cornering and top speed capability.
At the time, roof is far from a household name, and the machine sneaks onto the scene with minimal fanfare. Little does anyone know what will happen next.
I'm personally more surprised when something unexpected comes from a mark or a company that doesn't really play in that supercar space. Whether they purchased the technology, whether they created it in-house, the thing that draws my attention typically is the fact that here's this company that I had this perception about that's created something that's totally off the wall and totally out of left field that they technically have no right to be building, but it's awesome and amazing, and kudos to them for that.
In 1987, Roof obtains legendary status thanks to a magazine comparison test, where it hits an astonishing 211 miles per hour and earns the nickname Yellowbird.
What helped solidify Roof as an important maker of components and aftermarket tuning was a car called the Yellowbird. This is a car that the Road and Track editors said, let's put it on the track with these other supercars. Let's see what it can do. Maybe it'll outpace a couple of them, but we're not expecting much. It blew the doors off the competition. It outran every other car.
The Roof Yellowbird puts the world on notice that boutique constructors can compete in the supercar arena. A message that's heard loud and clear on the west coast of the United States, where a small volume bespoke manufacturer bursts onto the scene with an audacious dream and an outrageous design. The Vector W8.
It was a very significant car and one of the most sought after collector cars today, without a doubt.
Hailed by many as the first modern American supercar, the Vector W8 is a seldom discussed machine born right in Los Angeles. Like the Hollywood stars that call the area home, the W8's intention is to turn heads and shock the world.
It was one of the original supercars.
The machine features a turbocharged 6-liter V8 engine that's bolted directly to a 3-speed automatic gearbox. The result is a claimed top speed of 242 miles per hour. Just 17 machines are built before the mark goes bankrupt. However, the heady top speed accomplishment remains a daring example of what a small car maker can accomplish.
Eventually, supercars were getting to the point where the technology didn't advance by leaps and bounds. It had started to advance incrementally.
As the 80s come to a close, the term supercar is liberally applied to an expansive list of machines. Some merit the designation, while others do not. Yet by and large, they all require an owner to be willing to put up with their temperamental nature. That all changes in 1990, thanks to a machine from a different shore, the Honda NSX.
The original NSX was the game changer, and that was really, truly the first of the everyday supercars.
And then, of course, there was the NSX, which kind of turned the tables on what to expect from a supercar. All of a sudden, you had a supercar that you could drive every day, or drive 200,000 miles and not take out the engine to change the timing belt.
The NSX is built by Honda, yet badged as an Acura in the North American market. Right from the start, it's designed and engineered to defeat Ferrari at its own game.
The Acura NSX was the first comfortable and comfortably affordable supercar.
It was a car that was incredibly powerful, great to drive, looked cool, mid-engine layout, all of that. But you could also, just drive it in traffic. It was quiet, it was comfortable, it was easy, it was nice, and it wasn't insanely expensive.
The NSX offers a unique blend of high performance and civility. Drivers no longer need to worry if the machine will start in the morning or make them feel knackered at the end of a sporty excursion.
When the Acura NSX came out, the motoring public almost didn't believe it. They said, what is Acura doing making a car like this? I mean, they're a luxury manufacturer. I have a 4-door sedan with marvelous air conditioning and wonderfully plush leather, and here they come out with this? It doesn't seem very Acura-like.
Track tested by legendary Formula One champion Arian Senna, the NSX is built to offer Ferrari performance with daily driving reliability at a reasonably affordable price point. An unheard-of combination that radically realigns the supercar space.
One of the things the NSX has going for it is Honda/Acura reliability and quality. But as good as that seems, supercars and hypercars, they almost need to be impossible. They almost need to be temperamental. It's like you're engineering the soul out of a vehicle if you make it too civilized.
The NSX is a convention-challenging machine in more ways than one. It features a 3-liter V6 with variable valve timing that makes just 270 horsepower.
The NSX was truly the idea that a supercar could be driven by you, and you could drive it every day. It wasn't just this crazy thing that had to live in the garage of your private house on some island. It was, you can drive an NSX every day. You really could.
Innovative in both design and construction, the NSX is the first production car that pairs an aluminum monocoque with cutting-edge materials like titanium. The result is an extraordinarily low curb weight that rings the register just over 1,300 kilos.
What Acura was doing with the NSX is what BMW did with the M1. They took everything they knew about how to make a civilized car and everything that anybody had ever learned about how to make a performance car, how to make a performance car package, and embody those things in the same vehicle.
The NSX alters the supercar landscape by changing the perception of what it's like to live with a fire-breathing, high-performance machine. It's just one more way that supercars are changing.
There's so much to performance and great driving dynamics and all that that is so technology-focused now. The way to beat everyone else is to just make little tiny improvements. We're gonna be faster, we're gonna have more power, or grip, or we're gonna have a faster lap time around this track.
For nearly the entirety of the automobile's existence up to this point, the 200-mile-per-hour barrier seems unassailable in a production car built for the street. Yet by the end of the 80s, car constructors are regularly doing the impossible and cracking the mythical double ton.
To have a car that you can park in your driveway that goes 200 miles per hour, that's saying a lot. That's quite a statement. Ferrari was the first there, and they got the publicity from it.
Breaking the 200-mile-per-hour barrier is a major step in the evolution of the supercar and the science behind it. While engineers enter a new technological age, the massive achievement comes with the realization that the future holds even greater challenges.
Think about what the definition of a supercar used to be, right? Thinking in the 80s, when everyone had to have a Testarossa or a Countach. They were hard to get in and out of. You couldn't see anything out of them. They were loud and uncomfortable, and the interiors weren't great. But they made beautiful noises, and they were really fast, and they looked amazing.
Weird thing about breaking speed barriers is that there's no reference point. We go 400 miles an hour in jets, right? We fly across the country or we fly around the world, but we don't have a physical reference point. You don't feel the effects of that speed on your body. And until you do experience that, you don't really have a concept of what kind of technological and physical barriers you've broken.
By the end of the 1980s, supercars are a household term globally. Otherworldly machines that look like spaceships and perform like aircraft, but on the road. These remarkable engineering exercises take flight in our imagination, yet also help transform ordinary cars for everyday driving. And the best is yet to come. They have hundreds of horsepower, million-dollar price tags, and lap times that make most race cars blush. Supercars, the most technically advanced form of the everyday automobile.
The race for the supercar is essentially about finding a way to get from point A to point B at speed with a little bit of fun in between.
With cutting-edge tech, exotic designs, and blistering performance, supercars represent the very best of the automobile. And an advanced test bed for everyday automotive engineering solutions.
You will never see a grown man or woman giggle more than when they hit the throttle on a supercar and just go all out in it.
This is the story of mankind's relentless pursuit for speed, the remarkable machines that brave the way, and the amazing evolution of supercar tech. The automobile was born in 1886. It takes an additional 80 years until the introduction of the world's first supercar, and another 40 years beyond that for mankind to perfect the concept. However, by the early 1990s, high-performance motoring DNA evolves with such vigor that nearly anything seems possible.
These kinds of vehicles have always been aspirational, and whether you started out as a young person really loving vehicles or you sort of developed it later in life, they all have a certain ambiance around them that makes them special, unique, and different in a world that sometimes seems like they're all the same.
Early supercars were an outgrowth of racing. However, by the 90s, the zenith of on-road sporting machines have developed into their own specific genre. While they might not race, supercars push the boundaries in every other conceivable way.
Racing's changed so much, there's no need to homologate cars anymore, and so now supercars exist as their own animals.
The apex predator of supercars arrives in '92. A stunning machine, often spoken about with reverence and awe. An all-conquering supercar, built by timeless engineering prowess. The McLaren F1.
The McLaren F1, the last of the weird non-computerized supercars.
The F1 is a cost-no-object approach to car building and is such a leap ahead in almost every imaginable way that it changes how we think about supercars. The machine's guiding principle is efficiency, and McLaren's obsession with weight reduction is the stuff of legend.
I mean, it's got a seat in the middle, first of all. Like, no other car has a seat in the middle.
And it sat 3 people, the driver in the middle, and 2 very friendly, trustworthy people, one on either side. This is a car that flew in the face of every convention.
The F1 is revolutionary because it takes advantage of new discoveries in material science and changes how car engineers think about building their machines. Prior to its introduction, most cars use fairly common materials, such as steel or aluminum. But after the F1 drops, every marque starts hunting for new substances to make their machines faster, lighter, or stronger.
The '92 McLaren F1 was super cool because it was a car designed to be the fastest it can possibly be and nothing else. We are going to make the most extreme car we possibly can, and no one gets the opportunity to do that anymore.
The F1's crowning achievement lies beneath its bodywork. It is the very first production supercar to feature a carbon fiber monocoque.
A monocoque chassis is a single tub that forms the structure of a car.
Monocoques are first developed for Formula One race cars in the early '60s. It takes nearly 30 years before they find their way into exotic supercars.
Whereas a lot of other cars, there's the platform and then the bones that go on top of them. This is a single piece that forms the shell of the car. It's the whole component of the body structure of the car, and it's one solid piece, which makes it super strong.
Traditionally, a car body sits on top of a frame. However, a monocoque is a single structure that integrates both the body and the chassis together in a single super strong piece, which helps save weight and increase rigidity.
So you have basically three parts that create this entire car. You have the monocoque, which is the center section, and then you bolt on your engine and rear suspension and your front suspension.
It makes your supercar better because it makes it stronger. The strength and stiffness of the body is key with performance.
The F1's monocoque is revolutionary, yet its engine bay is equally outlandish. It's lined in gold leaf to help dissipate heat and harness the power of a 6.1-liter BMW-sourced V12 that cranks out 627 horsepower.
If you were around in 1992 and you heard the name McLaren, chances are your mind would immediately have gone to the racetrack. But McLaren had bigger plans. This is a company with aspirations. This is a company that said, you know what, we've got all this engineering expertise. Let's build something that's incredible. Let's throw out the rule book.
The F1's mega motor pushes the machine to an absolutely absurd 231 mile/hour top speed.
So what they ended up doing is building a vehicle the fastest of its day, sexiest of its day, the most expensive.
It's a global economy of speed that takes some of the best minds in the world and the best engineers in the world and the best designers in the world at the time to create this great-looking car. It was a game changer.
The McLaren F1 earns the title as the world's fastest production car, and amazingly stays ahead of the competition for 13 years before it's overtaken by the Bugatti Veyron. It's an incredible scientific achievement for speed.
It's celebrated because it was just this engineering above all. It was a car designed to be fast as humanly possible, and that's it. It was not designed for any other reason. And I love that.
The McLaren F1 was a lightweight carbon fiber, incredible car that at the time was considered ridiculously expensive at being nearly $1 million, and now they're worth, 10 to 20 times that amount.
Today, the McLaren F1 is a highly prized collector car. However, it changes the supercar scene by bringing exotic materials to the forefront and leveraging the marque's Formula One know-how with ultra-rare elements like titanium, magnesium, Kevlar, and gold in the same car. What starts as high-end tech is now more mainstream, trickling down to machines like the BMW i3, a compact car that utilizes its own carbon fiber monocoque.
It even used gold as part of the heat shielding in the engine. Nothing else would do it.
The machine's most noteworthy advancement is how it moves material science forward and forges the mold that all future supercars will follow. In particular, the F1's liberal use of carbon fiber.
Carbon fiber. Strong and light and durable and expensive.
Carbon fiber is made from thousands of tiny filaments, which are bundled together in tiny strands and then carbonized before being woven into sheets of material. These sheets are then formed around molds and injected with polymer. The resulting piece is both strong and light.
If you engineer it properly, you can get it to collapse, you can get it to crash beautifully, and it's what's used in Formula One cars, and it's what's used in the most exotic cars today.
In the right applications, carbon fiber is 5 times stronger than steel and twice as stiff.
If you make a car light, that just has so many benefits. You don't have to make as much power, you get better fuel economy, and the strongest and lightest material that we use in cars is carbon fiber.
The F1 helps carbon fiber become the go-to material for modern supercars. On any given application, it weighs 5 times less than steel.
It's a lightweight thing, but it's ridiculously strong. And that's a great foundation for a supercar to start from.
While McLaren captivates the supercar scene, it's an old-world, old-guard English sports car constructor that proves to be its biggest immediate rival. In 1992, Jaguar introduces the XJ220.
It's just pushing the limits of what a road car can actually be. How do we make a road car that's like just barely a road car?
According to legend, the machine is conceived by company engineers in their spare time. Yet the XJ220 holds so much promise that company executives elect to put it into production.
A car that really set the standard for sports cars that came after.
When the machine debuts, it's the fastest production vehicle ever built by Jaguar up to that time.
It's like nothing you've seen before, and the design has influenced so many other brands and so many other sports cars in particular.
The XJ220 is not very well received and ultimately deemed a failure. Many potential customers complain that it's powered by a relatively small six-cylinder engine instead of a more era-appropriate V12 power plant.
There's going to be a buyer for a quote-unquote supercar who wants, to a certain extent, an old-fashioned experience.
While the XJ220 doesn't sell well during its day, its reliance on a smaller displacement engine ultimately ends up being a window into the future. Today, many top supercars use V6s in place of larger displacement V12s.
As Raymond Loewy, the great industrial designer, said, it's okay to be different, just don't be too different.
In the early 90s, it might have felt like the supercar's greatest innovations come from England. However, back in Italy, a few daring engineers plot the next great leap into the unknown. For over a century, basic automobiles transformed civilization. And supercars, the most technically superior variants, redefine our understanding of speed.
This is a car that is going to set records, break records, beat everyone else, and just be the best absolute brand possible.
During the early 1990s, English car constructors take the lead in the increasingly competitive supercar race to see who can build the fastest and most extreme machines. But back in Italy, the supercar's ancestral home, a collection of talented engineers aim to reclaim the throne.
It's not only that Italy is a small country, the place where they all come from is a small place. All of the car builders came from the area around Bologna, which had been historically a metalworking area of Italy.
Since the debut of the Lamborghini Miura in 1966, one place above all others has been the cradle of the supercar, the Emilia-Romagna region of northern Italy, a place where supercars embody the country's heart and passion.
Germany was the tradition of engineering. Great Britain was the tradition of sportsmanship. France had the tradition of elegance, and Italy had the tradition of speed.
An Italian supercar does more than just reveal the heart of the country. It also captures its soul. Perhaps no machine distills the passion, flair, and style of Italy like the Lamborghini Diablo. In 1990, no new car faces higher expectations. The Diablo has to replace the iconic Countach. It's no mean feat, so designers and engineers craft a softer shape that evokes the machines that came before it while modernizing it as well. The Diablo is powered by an enormous 5.7-liter V12 that features computer-controlled multi-point fuel injection. It cranks out 485 horsepower and helps the machine break the 200-mile-per-hour barrier.
The Lamborghini Diablo, which was the first computer-controlled fuel-injected Lamborghini.
Later Diablo variants will add power steering, four-wheel drive, anti-lock brakes, and adjustable spoilers during the machine's 11-year run. A collection of tech that ultimately trickles down to mainstream cars, and today is standard equipment on numerous machines.
You have cars in the 80s like the Diablo. That kind of plays into the idea of the excess and the idea of the crazy wedge-shaped aspirational stuff.
The Lamborghini Diablo isn't the only machine replacing a legend at the dawn of a new decade. In another part of Italy, a team of dedicated engineers attempt to rekindle the Bugatti magic with the introduction of the EB110.
The EB110 was a fantastic car. It was a game changer because it was the first ever car to have a carbon composite chassis.
The EB110, the most advanced and powerful super sports car and an icon of its time.
Introduced in Paris on September 15, 1991, the EB110 once again thrusts Bugatti onto the world stage. It is one of the first series production cars to be made exclusively from carbon fiber and weighs just 125 kilos.
The EB110 was this kind of revival of Bugatti, and again, it was a no-holds-barred kind of car that was going to turn the world on its head and put other supercars on notice.
The radical-looking machine is powered by a high-revving quad-turbo 3.5-liter mid-mounted V12 engine that spits out just over 550 horsepower.
It had all-wheel drive, it had active suspension, a carbon fiber monocoque chassis. This was cutting edge.
The EB110 is a true technological tour de force that unfortunately falls flat due to a global economic crisis. The few examples that make it out of Modena are arguably the most meticulously engineered and cutting-edge supercars of the 90s. The machine continues the supercar's push towards carbon fiber, thanks to its state-of-the-art monocoque. Yet the EB110 also ups the ante in terms of power. In an era when engines are increasingly getting larger, the Bugatti team opts for a smaller displacement power plant that uses 4 turbochargers to generate over 500 horsepower.
But in terms of a road car, a production car, it was 10 years ahead of Lamborghini, for example.
While the EB110 rocks the supercar scene thanks to its advanced tech, back in Detroit, otherwise known as the Motor City, a few faithful hot rodders come up with a different plan. In 1992, the stodgy Dodge Corporation is looking for a way to revitalize their image. Company president Bob Lutz has an idea. Why not build a back-to-basics supercar? The result is the Viper, a modern-day mega-horsepower, all-American rocket.
It started out as a project between a bunch of nut jobs in Dodge, and they make this car that just blew everyone away.
It was a cool engineering exercise, and it got people really excited about America.
The Viper features a gigantic 8-liter V10 engine that pumps out 400 horsepower and launches the machine from 0 to 100 in just 4.2 seconds.
When it came out, it was gorgeous, it was fast, it was loud, it did everything something that looks like this should do.
The Viper doesn't push the boundaries of science the way other supercars of the era do. It forgoes fancy computer tech that makes driving easier, and instead asks its pilot to do all the hard work.
The Viper is a very difficult car to drive. I mean, it would literally burn you when you were getting in and out of it because of where the pipes were in the bodywork on the side of the car.
The whole point of the Viper is to go fast, stop hard, hang in the corners, and give everyone a thrill. In many ways, it's the anti-super supercar.
The Viper isn't something you're going to want to take on a road trip. It's not something your wife is probably really going to like. Its sole mission is go have a lot of fun.
While the Viper is all muscle and grit, back in Italy, Ferrari engineers go to the extreme in the opposite direction. In 1995, they introduced the F50.
The F50, again, Ferrari's statements about what the future of speed will look like.
The machine harnesses the power of a naturally aspirated Formula One-derived V12 that's paired to a manual gearbox and wrapped in a carbon fiber chassis. The result is one of the most revered and hallowed supercars of all time.
The F50 is a standout because of its brutality. It looks like such a muscular car. It's got bulges everywhere you would expect a muscular car to have them. It's got an engine with an incredible sound. And the top came off. Here you had an open car in an era where most cars were closed.
Known as one of the greatest analog machines, the F50 pushes Ferrari into new territory. It's the marque's first road-going machine to feature a carbon fiber monocoque. It also harnesses a fully independent suspension system that borrows elements from Formula One, including shock absorbers with adaptive damping control and electronic height adjustment.
When the F50 came along, they intentionally made one fewer than their marketing experts thought that they could sell, just to keep the exclusivity alive.
Exclusivity has long been a hallmark of the supercar scene. Yet as the 1990s comes to a close, the traditional players are about to be blindsided by a boutique brand with big dreams. By the tail end of the 1990s, the landscape of the automotive industry is seismically shifting. Advances in technology, material science, and aerodynamics push the supercar into new and uncharted territory. It is the birth of the hypercar era.
If a Toyota Camry suddenly has 300 horsepower, a supercar should probably have at least double that, if not triple that. As regular street cars became more powerful, supercars had to compensate, and they had to widen the gap between themselves and the regular cars. Cars became mega powerful, and we see the incredible 700, 800, 900 horsepower supercars that we have today.
One of the first machines to vie for the hypercar title comes from an artisanal bespoke car constructor in the heart of Italy's Motor Valley, Pagani. The marque might not be a household name, but in 1999, it shocks the world with the introduction of the Zonda C12.
The 1999 Pagani Zonda comes out, and it looks and sounds and goes like nothing else out there. It's insane, and no one sees it coming.
Companies like Pagani, they're really like the Fabergé of car makers. They do very few cars, and they're very expensive, and they're done to a very high standard of art.
Orazio Pagani founds his namesake company right under the noses of Ferrari and Lamborghini. The Zonda C12 is his entrance into the supercar club. When it arrives, it has no racing heritage or supercar glam, just a massive amount of carbon fiber excellence.
If you can get a small company to come in and the only thing they care about doing is insanity, this crazy supercar, they'll do it right because it's the only thing they're focused on.
The Zonda is fast, sexy, exotic, and extreme. It quickly becomes one of the most highly sought-after machines in history, thanks to its top-flight performance.
The power, the low weight, the acceleration, the top speed, everything, it's all just, we're gonna do only the extremes. I mean, we're a car company that you've never heard of before, and our first thing that we come out with is gonna beat everything else. Crazy to me. I mean, it takes the world by storm.
Some car aficionados believe that the Zonda is the world's first true hypercar. What isn't debatable is that for a car like the Zonda to exist, supercar tires have to level up.
Tires can change everything, in terms of what a car can do.
The ethos of supercar design is tailored around maximum performance. Tires are not only the vehicle's point of contact with the road, but a key ingredient in their ultra-high-speed runs.
The single most important part of a car is the tire, because that is where all the power gets to the road. If the tires are bad, the car is bad. And there are so many times where you drive a car and you say like, oh, it's one set of tires away from greatness.
In the 90s, tire manufacturers started using more silica in their tire compounds, which increased tread life, but also gave tires a lot more dry grip. And they've continued to hone that and to perfect that.
Supercar tires must defeat real-world physics at every turn. They're constantly battling against centrifugal, cornering, acceleration, and braking forces.
The tires that can run consistently at 200 miles per hour and not burst, it's quite an achievement. They're very expensive and they're generally purpose-built for each car.
Tires are extremely complex. They are not just rubber rolling things with a tube in the middle of it. It's not the case anymore. You've got car companies working with tire makers to develop tires specifically for an application on a specific car.
As the faster you go, the more the tire expands through centrifugal force, and the more heat is built up. So it puts extreme demands on the carcass of the tire to maintain its integrity.
As the 2000s approach, tire manufacturers begin custom tailoring their products for each specific supercar. The race to hit higher speeds leads to new complex compounds that give tires longer life and better grip, tech that ultimately trickles down to regular cars as well.
Today we have long-wearing tires that have the grip of race car tires in the 80s. Cars regularly pull over 1G, which was something that just didn't happen. 20, 30 years ago, if a car pulled 0.9 Gs, that was like out of this world. That was like incredible. And now we regularly have cars that pull over a G and are basically daily drivers.
We're taking tire tech in a way that makes cars handle it with levels of grip force that we've never seen before, to doing things that will also make you safer in the snow.
In 2001, tire tech is pushed even further with the introduction of the Lamborghini Murcielago. The machine ushers in the 21st century with a bang. It is the exact definition of a supercar, incredibly powerful, undisputably fast, and flamboyant in every way.
They were great cars, but they were really pushing the boundaries. That led to some triumphs, more victories than defeats, but it did lead to some challenges.
Designed as a supercar for the 21st century, the Murcielago is Lamborghini's first new design since the inception of the Diablo in 1990. The machine moves the game along thanks to its structurally stiffer chassis. The firmer a chassis is, the better a car can perform because it reduces the movement of everything bolted to the structure. Today, the structural integrity of everyday cars is higher than ever before, thanks in large part to advancements found in machines like the Murcielago. As Lamborghini perfects the art of rebellion, a short distance away, their Italian rivals are about to drop their biggest sensation of the 21st century, the Ferrari Enzo.
In the early 21st century, the Ferrari Enzo was the hypercar. And it sort of followed in the line of the 1984 Ferrari GTO, and then the Ferrari F40, and the Ferrari F50, and then the Enzo came next.
The Enzo, in its sort of breadth within the Ferrari portfolio, it is so unique looking that it really just captured a lot of imagination.
The Enzo is a V12-powered mid-engine monster, named after company founder Enzo Ferrari. When it drops, it immediately becomes the new benchmark that all supercars and hypercars are measured against.
The Enzo, again, it's that halo car. It's this homage to what Ferrari can stand for. We're gonna build a race car and we're gonna sell it and you can drive it on the road. It was wild looking, totally wild looking.
The Enzo is wild, thanks in large part to its exterior packaging. Just as aerodynamics dominates Formula One cars, form follows function on the Enzo. To pierce through the atmosphere with minimum disturbance, engineers designed the machine to cut through the wind without any pronounced wings.
If you look at Ferrari's past limited edition hypercars, they have always been a statement about what Ferrari thinks the future of speed looks like. A lot of people didn't like the looks of the Enzo. And it had this long nose, and it had movable aerodynamic elements, and the styling of the car was somewhat beholden to its purpose. It was not styled to be beautiful, it was styled to be fast. And what Ferrari was saying with the Enzo was, this is what speed looks like.
The Enzo uses clever aerodynamic tools to produce downforce and eliminate lift. The low, angular front helps pin the nose of the car down in faster corners, while the rear diffuser and flat floor negate the need for a large rear spoiler.
Ferrari's been building these technological tour de force cars where they throw all their technology. It's basically a test bed for all the future Ferraris that are to come. And that's what the Enzo was. Really powerful V12, lightweight, carbon fiber car.
To improve airflow around the car at speed, the Enzo features a pair of countersunk air channels that start just after the front radiator outlet, wrap smoothly around the greenhouse, and then gently open up again at the back of the machine.
When it came out, it was incredibly iconic because it was so different from a lot of the other stuff that you've seen on the market at that time. It was striking, it was typical Ferrari, loud, raucous, sharp, edgy, sort of defined in this way. It was nothing like you'd seen prior to that unless you were at an F1 race.
The Enzo's design sort of pushes the envelope of what car design can be. A lot of it's engineer-driven, a lot of it's wind tunnel-driven, a lot of it is driven by, downforce and aerodynamics. But Ferrari has always kind of pushed the envelope of what you expect a Ferrari to look like. And that sort of makes people uncomfortable sometimes. That car looks kind of odd from some angles, but in the end, it sort of all makes sense, and it does end up being beautiful. And if anything, we might say it's ahead of its time.
During an era of maturing engine technologies, the Ferrari Enzo perhaps best represents the last vestiges of naturally aspirated mechanical hypercars built before full electronic intervention. The V12 cranks out 650 horsepower. The single-clutch automated manual 6-speed Formula One style transmission is capable of cracking off shifts in just 150 milliseconds. Shockingly quick for the time. Put it all together, and the machine can hit a wicked 217 mile/hour top speed.
The Ferrari Enzo set the challenge. Okay, I defy you to produce a car that's as stable as this car, but also beautiful. And that's what designers have really been working on since the Enzo, is produce a supercar that has that kind of performance, is stable at those kind of speeds, but also is appealing to the eye.
The Enzo is designed to push the performance boundaries for what is possible in a road-going super machine. Many believe it's Ferrari's first true hypercar.
By the time Ferrari got to the Enzo, they had developed piston engine supercar about as much as anybody possibly could. It embodied every mechanical feature that made it go faster. It embodied every visual cue that made it look better. It was one of the last cars that helped signal the beginning of a transition.
The Enzo's clean sheet Formula One inspired design is an instant success. All 399 examples sell out, and today are worth millions on the collector market.
The engine was Formula One derived, the suspension was Formula One derived, everything about the car, even the steering wheel design and controls and so forth, all just like on the Formula One cars. In that sense, maybe the ultimate fantasy car, but it was in fact a reality. It was, one of the watermark cars in supercar history, without a doubt.
That sort of wedge-shaped sports car was really a thing, and that was the thing that Ferrari was always really good at. They combined an aerodynamic shape with a striking look. It made it stand out in a field that was still, back in the curvy, soft forms of sort of sports cars and race cars even.
As Ferrari gets more extreme, In Zuffenhausen, Germany, a team of talented Porsche engineers reimagined the hypercar the Porsche way. Their hard work pays off in 2003 when the marque debuts the Carrera GT. It is the holy grail of analog hypercars.
Since 1963, Porsche is kind of synonymous with the 911, which is flat six, rear-wheel drive. Then you've got the Carrera GT, which has a mid-engine V10. It has a carbon fiber tub. It shares practically 0 parts with any other production Porsche, a complete departure from everything that Porsche has been known for up until then.
The Carrera GT is considered by many to be the greatest manual gearbox sports car ever made. It features a racing-derived 612 horsepower V10 engine that is as cutting edge as it gets at the time, thanks to variable valve timing, titanium connecting rods, and a 68-degree V-angle.
The Carrera GT was a carbon fiber car, so it's Porsche building a car out of carbon fiber, out of the lightest, strongest material, something that's used in race cars. And it also had a V10, which was unusual because it came from a race car that never happened. It has a technologically advanced, high-revving, incredibly sounding race car engine in it.
The Carrera GT isn't the flashiest or most flamboyant machine of its time, but it's built with traditional Porsche attention to detail and offers an exquisite driving experience.
The sound of that engine, oh wow. Extremely high revving. It was, ring, ring, like a ripping canvas, as the saying goes. That was not a typical Porsche sound.
It was just this embodiment of technology and meticulous engineering that really just kind of mopped the floor with anything around it.
The combination of a 6-speed manual transmission, no electronic aids like stability or traction control, and a massive high-horsepower engine make the Carrera GT one of the seminal hypercars of the era and a landmark machine.
With the Carrera GT now, we sort of look back at it as one of the last quote-unquote analog cars. It wasn't completely driven by computers. It still allowed the driver to do his thing. It still had a manual transmission. It wasn't a dual clutch automatic like so many cars are today. The driver was still really part of the experience. That's sort of what makes it special.
The machine's success highlights Porsche's fastidious detail to shaving mass. The Carrera GT weighs just 1,380 kilos.
It's all about the most power in the lightest possible way, but not so much or little that it screws with balance. It's all about, having an engine be able to work as hard as it can and to move the least amount of mass around.
When it comes to unadulterated speed, a hefty horsepower figure and heady torque curve are just part of the equation. A vehicle's weight is equally important, which is commonly referred to as its power-to-weight ratio. A calculation that compares 1 unit of energy to 1 unit of mass, independent of the vehicle's size. Leveraging a great power-to-weight ratio is crucial for top-flight supercars. In 2004, fabled Italian marque Maserati decides to jump back into road racing with the introduction of the MC12.
It raises the benchmark ever higher and higher and higher. How high is up? Well, maybe we'll find out someday. Just a phenomenal car. Very few are made, and a very lucky number of people own the cars.
The MC12 is based on the same platform as the Ferrari Enzo. When the marque sees an opening to take the machine racing, they retool the car. First, Maserati extends the body and adds a fixed wing and wider body panels. Then they turn around and build 25 examples for the road to qualify the machine for the series.
How do we make a road car that's like just barely a road car? Like, how do we make this a race car that you can drive every single day? How do we, blur that line between race car and road car? And how do we do it in a way that's like so exotic and so exclusive and so cool that you don't really understand it, but you want one?
The early aughts see a veritable explosion in the ultra-high-performance supercar and hypercar sectors. Machines that continually challenge expectations while offering a glimpse into our collective motoring future. The supercar genre has always stood at the forefront of technology and progress. As the aughts kick into high gear, high performance, passion, and engineering know-how come together in new ways and new machines.
You've got a lot of significant supercars that have continually redefined the rules of what a supercar stands for and what it represents.
In the early 2000s, the elevation of the hypercar genre not only redefines sporty cars, but also challenges their less powerful but still utterly awe-inspiring supercar siblings to step it up a notch and become reliable and safe everyday drivers.
It's when you realize that you still have to sell a few. You can make this crazy feat of engineering, but if you can't put airbags in it and you can't put a good infotainment system in it, no one's gonna buy it. You still have to make it usable day to day. I think you talk about packaging when you talk about the idea of the everyday supercar.
Perhaps the best example of the supercar coming of age hails from Italy. In 2003, Lamborghini introduces their new entry-level machine, the Gallardo. It doesn't challenge supercar convention or chase hypercar performance numbers. Instead, it perfectly combines the Lamborghini experience with everyday driving abilities.
And it was the first car developed and produced by its new owner, Audi.
The Gallardo is the machine that modernizes the house of the raging bull and changes its trajectory, cracking open a new market of high-end buyers and performance drivers. For the first time, a Lamborghini machine isn't temperamental or best used solely on a racetrack.
So you had Italian passion governed by German precision. The Gallardo was the first modern Lamborghini, and it was something that could almost be a daily driver if you wanted a V10 supercar as your daily driver.
The Gallardo and its eventual successor, the Huracan, also highlight another feature of the modern supercar scene: platform sharing. Developing and engineering a super sporty machine becomes so expensive that car constructors begin leveraging assets from their other corporate brethren.
The Audi R8 was so radical when it first came out.
The introduction in 2008 literally changed everything.
It had a design that was so unique and so different than the establishment.
Kids started pinning pictures of the R8 to the wall.
It attracted attention wherever it went. And when you see one on the road today, you still think, oh my God, what was that?
The R8 really made the supercar approachable and, dare I say, accessible. It was not nearly as expensive as a Ferrari or a Lamborghini. You had all the sexiness and the attractiveness and the head-turning ability of a supercar, and you had incredible performance too, but at a more approachable price.
My favorite supercar that I've driven is probably the original Audi R8 because it looked like nothing else. It had that awesome side blade. It had a really great V8 engine. It had a manual transmission with a gated shifter. It was one of the most visceral driving experiences I've had in my life.
While Audi and Lamborghini are finding ways to economize their supercars, back in America, the Ford Motor Company takes a different approach. Designed in secret to celebrate the marque's historic 1966 win at Le Mans, in 2005, the Motor Company introduces the Ford GT, the marque's first true supercar.
The Ford GT announced to the world, hey, Americans can build supercars too.
The 2006 Ford GT. That car, it was like nothing else I had ever been in, is still like nothing else I had ever been in. It was crazy. I love that car.
When the machine launches, it's immediately hailed as the next big thing by auto enthusiasts, and is America's only true supercar at the time.
It's definitely a halo car, limited production. What it says is the company is capable of producing good cars or trucks in all of these market segments. Pick a choice. They're all good. And the fact that we can make a Ford GT shows that, yes, we can do something even that exotic. So, gosh, our trucks must be pretty good, our sedans must be pretty good, because look what we can do.
As the aughts begin to wind down, the fascination with supercars ratchets up again as new challengers emerge from different parts of the world, even including Sweden. Boutique Swedish supercar constructor Koenigsegg blasts onto the scene and introduces the first road car to top the famed McLaren F1 speed records. In 2006, Koenigsegg debuts their third-generation machine, the CCX. It's their first vehicle built for the global market and a harbinger for what comes next in the supercar space.
It was sort of cutting edge in terms of the speed and the lightness of the car. They really had to go into areas to boldly go where no manufacturer had gone before.
The body and chassis are virtually all carbon fiber, which helps the CCX taper down to an impressive 1,179 kilo dry weight. The machine's low mass is paired with an all-aluminum 4.7-liter twin-turbo V8, capable of generating over 800 horsepower. Mega numbers for a brand new entry into the supercar genre, and a machine with a mental power-to-weight ratio.
Koenigsegg found a business case in building the fastest, the outright fastest cars they can possibly make. So everybody's looking for a little fissure, a little white space where they can hopefully eke out enough money to survive.
For over a century, automotive pioneers have pushed the boundaries of what others thought were possible, all in the name of speed. The machines they create sit at the absolute zenith of high performance, and for years help dictate where the ordinary automobile is headed.
Supercars could go out on a grid of almost any race series and set competitive lap times. And that's simply because racing series today are so controlled and so limited in the technology they can use, whereas the supercars can use anything.
From the dawn of the automotive age through the new millennium, the quest to engineer better, more refined, and even faster machines has been a hallmark of motoring, a global competition that sees numerous challengers all aim to best their rivals, and the ultimate example of mankind's need to explore the upper limits of science, speed, and physics. Supercars are amazing machines that transcend their basic transportation origins. Each is a relentless high-performance pursuit, and the science required to go even faster never stops and never sleeps.
How fast is too fast? There will always be a push to innovate and to keep moving forward.
The knowledge behind these amazing machines is an ever-expanding field full of imagination, where risk is rewarded and big dreamers often step out with bold ideas.
People that don't like cars love supercars. When you see one on the road, you can't help but point and look and stare at it.
No one knows which tech will triumph next, who will produce it, or what the next game changer might be.
And then they drive like a bat out of hell. Which is the allure of the supercar, right? It is just this utterly extraordinary thing that leaves you absolutely speechless, but then at the same time, it's like a rocket ship. It's crazy.
This is the story of mankind's relentless pursuit for speed, the remarkable machines that brave the way, and the amazing evolution of supercar tech. Since the birth of the automotive age in 1886, when German inventor Carl Benz bolts a small combustion engine onto a three-wheeled wagon, the pursuit to build a better automobile fuels the imagination of engineers and designers around the globe. In the 20th century, That vision fuels engineering pioneers to push the envelope of speed and handling even further, and results in the creation of some truly remarkable driving machines. However, at the dawn of the new millennium, the evolution of the supercar gives rise to a new category of machines, vehicles that early automotive forefathers could never have imagined.
A hypercar is take everything you know about a supercar and push the absolute limits of design and aerodynamics and power and capability and price and exclusivity. You turn everything up to 11.
Calling a car with a quadruple-digit power output by the same name as the supercars that preceded it doesn't do the machines or their incredible performance justice. By the early 2000s, a new term is needed to describe the absolute apex of the automotive world.
The hypercars are like $1 million, $2 million. They're all just special.
For over a century, the notion of a 1,000 horsepower car is only possible in the realm of comic books or science fiction fantasy. Yet by the 2000s, it's now a technical challenge on the cusp of being cracked.
What we knew as the supercar with things like the F40, there really became this like next step up. And it's like, well, do you call it like a super duper car? Or do you call it like a extra super, like what do you call it? And so hypercar kind of became this term.
The term hypercar is coined to qualify the absolute top 1% of all supercars. While all hypercars are supercars, not all supercars are hypercars. It's a subtle distinction that delineates machines with over 1,000 horsepower, first-class new age tech, million-dollar price tags, stunning design, and ultra-extreme performance. Almost every aspect of these cars advance the auto industry, and not a single compromise can be made.
As technology progresses, cars become more and more and more capable. Hypercars become more capable in terms of their speed, their braking, their handling, the lap times they can achieve, and ever continuing march upward. Where's the limit? We don't know.
There is going to be that point where you simply can't go any faster. And it's really interesting to kind of be on that ride to see where that takes us.
The dawn of the new millennium sees Freakonomics hit the high-end automotive industry when Bugatti debuts the ultimate feat of engineering. And a machine that alters the car industry forever, the Veyron.
The Veyron is a huge tentpole, is a huge, huge step forward.
When the Veyron drops in 2005, it's considered the absolute zenith of automotive engineering, and the stick against which all cars will now be measured.
The Veyron raised the bar of automotive performance to formerly unknown levels.
It's a technological tour de force. I mean, it's got 4 turbochargers, 1,000 horsepower, top speed of 255 plus.
Here's a car that is literally without compromise. Everywhere you look, this car was designed and defined by glorious, overwrought excess.
The Veyron is unlike any car that comes before it. And its existence rewrites the supercar space. A machine built to push the envelope and bend the laws of physics.
Some people would consider the Bugatti Veyron a supercar. Some might consider it a hypercar, which is sort of the next echelon up.
No car had been driven that fast before, and no car that big and that heavy with that much power had been able to do that sort of thing.
The Veyron represents a quantum leap forward for the possibilities in an automobile. It's built to achieve 4 primary targets: a 1,001 horsepower engine, a top speed greater than 400 kph, a 0 to 100 kph time less than 3 seconds, and it has to be luxurious enough to take to the opera. At the time, the combination of attributes seems ludicrous.
And the Veyron was different in that it was a luxury car. It was this big luxury grand tour. It wasn't trying to be a supercar in the way that a Ferrari or a Lamborghini or a Pagani was. It was trying to be this big, comfortable, crazy fast thing. It kind of redefined excess.
During the Veyron's harrowing development process, engineers burned the midnight oil while trying to build a super sports car for the road that's groundbreakingly fast, yet as easy to maneuver in a car park as a VW Golf. The result is a trailblazing machine that crushes the world's top speed mark and ushers in a new era of seven-figure super machines.
Their goal was top speed, and they met it. The things go over 250 miles an hour, and it's, the fastest car in the world.
The car on paper and in photos was so apart from anything else that was in that market. And of course, it commanded a price that was way above what anybody was accustomed to paying.
All that excess requires engineers rewrite the rule book while fitting 10 radiators inside the machine and developing special tires that can only survive 50 minutes of the car's insane top speed.
I think Veyron was really, truly when Hypercar became a thing we had to talk about, because Supercars existed when the Veyron came out, but the Veyron was so much more. And it's like, well, what do we call this?
You have to love Bugatti for its audacity. This is a car company that exists to be extreme. Extreme in design, extreme in performance, extreme in speed. This is what they do. They've never shied away from being a car for people that can afford the most powerful, the fastest, the most expensive car out there.
The Veyron carries a long list of firsts and cutting-edge tech, yet its crowning jewel might well be the machine's W16 engine.
Back in '99, the W16 engine was certainly nothing short of revolutionary.
When the W16 engine debuts, the most powerful supercar engine features 627 horsepower. The W16 ups the ante by an additional 374 horsepower. That's nearly the power output of an entire other motor.
It effectively set the development of the past 20 years, the run for new superlatives, into motion.
The W16 is basically two W8s crammed together at the crankshaft with 4 turbochargers.
The original W16 makes a staggering 1,001 horsepower, yet Bugatti engineers never stop refining their monster engine. Today, the same basic layout is capable of producing 1,850 horsepower, nearly double the original design. The W16 isn't the Veyron's only masterstroke of engineering. The machine also features a 7-speed dual-clutch direct-shift computer-controlled automatic transmission.
A double clutch transmission, or a dual clutch transmission, is a type of automatic transmission where a computer basically operates the clutch and the shifting for you.
A traditional manual clutch allows a driver to disengage the engine's crankshaft from the transmission so that a pilot can switch gears.
A normal car with a single clutch, the clutch has to release one gear and then grab the next one. With a dual clutch transmission, you have the one clutch on the one gear, then you have the second one ready to grab the other ones. So the transition is instantaneous.
A dual clutch transmission automates this process thanks to the addition of a second shaft. The magic of the dual clutch is that it can change from one gear to another lightning fast. Because while one gear is engaged, a computer pre-selects the next gear with the other clutch. It's immediately ready for engagement, which allows the unit to shift in mere milliseconds.
Dual clutch transmissions can shift faster than a conventional automatic, and more importantly, way faster than I can using a manual transmission.
You have your odd number gears operated by one clutch, and your even number gears are operated by the other. So when you shift, one clutch is releasing while the other one engages. So you get this perfectly quick shift.
The Bugatti Veyron is capable of astonishing performance with every press of the pedal. The machine's technology adds a whole new dimension to the automotive world. Yet as groundbreaking as the Veyron is, the evolution of the hypercar is just getting started. The supercar. It's a staple of bedroom posters. What many dream to drive, and few aspire to own.
Driving a supercar sharpens your focus in a way that an ordinary car doesn't. All of those layers are just peeled away. It just heightens your senses. The world passes by so rapidly. The engine is so loud. Your fingers are gripping the wheel and you can feel every edge of the car just talking to you. And, it's just this overwhelming sensorial feeling.
Overwhelming sensations lie at the heart of the Pagani experience. And in 2012, the marque blasts to the front of the pack with the introduction of the Huayra.
Pagani is definitely the jet fighter of the hypercar world.
When it debuted in Geneva, it was, basically the star of the show. Everyone was surrounding it, everyone wanted to check out every single little tiny detail.
The Huayra blasts from 0 to 100 kilometers per hour in just 3.2 seconds. It hits 200 kilometers per hour in just 9.8 seconds. A mere 25.8 seconds crosses the 300 kilometer per hour mark. Faster than a jumbo jet at takeoff.
There are expensive cars, and there are really expensive cars, and then there are cars that cost well over $1 million.
Named after a southern wind, the Huayra represents the culmination of 7 years of advanced engineering work and an entirely new take on the hypercar.
Pagani exists in a really rarefied air. Only the richest guys in the world who really love cars have one of these.
This isn't just a fast car. It's an experience.
While the Huayra is all kinds of good fun on the track, its ultimate claim to fame is the machine's active aerodynamic system.
So the idea of being active, meaning it can change all of the wings, is that when you're driving in a straight line, it's as slippery as possible for as high of a top speed as possible. In the corners, it'll sacrifice some of that speed for extra grip, which is what you need.
The machine features airplane-inspired flaps at each corner. The flaps move independently and alter the amount of downforce the Huayra experiences. The Huayra's active aero system helps keep it glued to the ground.
Downforce is using air to press down on the car. Lift is using air to pull up. We almost never want lift on a car because, of course, we don't want it to become airborne. But downforce is a good thing in the corners, but not when you're going straight ahead. Because to get downforce, you need to have aerodynamic drag, which means the car will be slower.
The active aero system helps stabilize the car at speed.
So the idea behind the ailerons is simple. If the flaps go up, they use the wind to push the car down.
In the corners, the flaps deploy to keep the car planted in the turn.
When you're going into corners, they can pop up to 20 just to push down on the car and help it turn.
During heavy braking, the system activates again, this time to generate additional braking force.
And under braking, they pop up to 40 degrees as kind of a parachute.
The Huayra's two-pronged approach reduces the coefficient of drag from 0.37 to 0.31, effectively shrinking the machine in size by 1/6.
As you can see the exact way that the air moves around and through and under and above a car, and you can design the car with that in mind. So you can actually put things like little tiny vent here that channels air a specific way through or above or around a car for maximum aerodynamics and maximum downforce.
While the Veyron and Huayra reshape combustion engine hypercars, a new type of powertrain tech emerges with sustainability at its core. The hybrid vehicle. The first mass-produced example is the Toyota Prius, a family car that combines an electric motor with a traditional petrol engine. What starts as a way to go green quickly becomes a way to go fast as well.
The science and technology and the engineering is a vital part of the supercar arms race. It is essentially companies throwing buckets of money at brand new engineers, brand new folks coming out of different aspects, everything from, plasma technology to composite technologies to things like electronics.
The continual march of technological advancement leads to a convergence of green dream machines. Somewhat improbably, Porsche, Ferrari, and McLaren all arrive at the same conclusion, that the next step in the supercar's story is hybrid tech.
The McLaren P1, the Porsche 918 Spyder, and the Ferrari LaFerrari all showed up at the same time, and they had all taken a hybrid powertrain, so an electric motor and batteries. Instead of using that for fuel economy, they used it to make even more power, so all of them were flirting with 1,000 horsepower.
You had kind of a trifecta of cars that represented the very best, the highest possible development of the kind of vehicle that defined a supercar.
You have this holy trinity of just mind-blowing performance that also adopts a more green approach to how that performance is achieved.
The three mega machines they create come to be known as the Holy Trinity. None of them are as powerful as the Bugatti Veyron, but it scarcely matters. Their relative lightweight and compact designs imbue them with a level of real-world performance that's in a different league.
It's a race to the top. It's essentially who can pack the most power into the smallest package that looks the best and that creates the most buzz.
This holy trinity of these halo cars that all came out, they all used hybrid technology. They all had electric assist, all for the sake of being super quick. They all looked insane. They were these great feats of engineering.
Three cars from three manufacturers, all released in 2013, come to define the hybrid hypercar.
It was as good as you could get. Engineers could not have helped but notice how interested the buying public was becoming in electric cars and gas-electric hybrids.
The three Holy Trinity machines all aim to be lightning quick. However, they all go about it differently.
That was the moment where, the supercar got electrified. That was when it suddenly became not just okay, but really cool to have hybrid technology in a supercar. The supercar that I know, it has to have a giant V12 engine. You just need big engine making big power, and it needs to be in the middle or the rear of the car, and that's it. But with these, it's like, well, we can use this smaller engine, and we can use this, electric assist to it, and we can get performance that's actually better than what those old supercars made. It just opens the world of supercars to this new segment of people that are more interested in technology.
Porsche focuses their development on merging two electric motors with a detuned version of their prototype Le Mans engine.
We've got the 918. Here we have a hybrid supercar with a huge stonking V8 and a tremendously powerful electric drivetrain working in harmony to just shatter all kinds of performance records.
The 918 gets 33 kilometers per liter. It can also rocket from 0 to 100 kph in just 2.2 seconds. Keep your foot pinned on the throttle, and you'll hit a mega 339-kilometer top speed.
I think that most automotive engineers are hedging their bets and saying, right now, electricity is probably the best way for us to go for all of our cars, or a car that burns hydrogen to create its own electricity, and that would be a fuel cell vehicle. Ultimately, we don't know where the future's going, but it looks like every probable direction is heading towards electric.
While the machine's performance is heady, it's the engineering solutions within the vehicle that change the game.
The 918 is super cool. It wasn't a full EV, it was a plug-in hybrid, but it was the first way of kind of showing people electric doesn't have to mean Prius, and hybrid doesn't have to mean slow. We can use hybrid EV technology to make a super fast, super cool car.
McLaren's P1 is radically different than the Porsche. It features one E-motor on the transaxle in conjunction with a twin-turbo 3.8-liter V8 that knocks out 727 horsepower.
anytime you get into an electrically powered car, whether it's just a pure electric vehicle or a hybrid that's electric intense, it is immediate psychotic acceleration. It's unlike any gas engine.
The LaFerrari is the most powerful Ferrari ever made at the time of its introduction in 2013. It's propelled by a combination of a traditional 6.3-liter V12 petrol engine and an electric motor regulated by a Formula One-inspired Hypercar system.
The Ferrari LaFerrari was one of the first sort of hybrid supercars that we saw come to market. Made it a really interesting entry from a technological point of view.
The LaFerrari is a powerful testament to passionate high performance that paves the way forward for one of the most storied motoring marques. It's also very different than the Porsche, using its E-motor to only deliver power to the rear of the machine.
When Toyota builds a hybrid, they build it to do fuel economy. When Ferrari builds a hybrid, it's just extra power. The electric motor is just extra power for the V12.
Despite the fact that I absolutely hate the name, it sums it up really well where it's the Ferrari. That's what it is. It's the Ferrari. There's no other way to describe it.
Unlike the 918, the LaFerrari has no manual deployment mode for the hybrid system. The company designs the machine to be focused entirely on the act of driving and the experience, not fiddling about with little buttons.
The LaFerrari is a vision of what Ferrari feels the future is at the time the car was produced. Obviously, it has a hybrid component. Ferrari believes that electrification is coming. It's unavoidable. No modern supercar is considered modern without it. Anything that doesn't have an electrical component is old-fashioned. So once again, Ferrari is making a statement.
Upon its introduction, the LaFerrari becomes one of the most sought-after cars of all time. Today, pristine examples change hands for $4 million or more.
The LaFerrari really kind of changed that game, and it was like the sort of automotive world went, oh, okay. So we're actually committing to this idea of getting more power, but not necessarily from petrol engines, more from sort of a hybrid setup, or eventually perhaps even totally electric.
All three Holy Trinity machines use hybrid technology to advance the automotive landscape with performance that could only be imagined in prior decades.
This is what the future of speed looks like. With modern materials and 20 years of development in computational fluid dynamics and all the tools that they have today, they're able to finesse these designs to also make them appealing to the eye in a way that classical cars are, with classical curves and forms that are universally appealing.
The Holy Trinity make technological waves in the supercar space. However, hybrid science has been around far longer than most people realize. The world's first hybrid automobile is the Lohner Porsche from 1901, designed by none other than Ferdinand Porsche.
The Lohner Porsche set the precedent for a modern hybrid car at the beginning of the 20th century, which is just kind of unheard of, especially with battery technology being what it was.
In 2018, Swedish supercar constructor Koenigsegg ups the ante and debuts the Agera. The turbocharged 5-liter V8 harnesses 1,341 horsepower to rocket to an absolutely insane 284 miles per hour top speed.
They experimented with several sections of the car to try and compromise between high-speed stability and keeping the car on the ground and not pushing it down on the ground too much. This was pioneering work at that time on cars of this speed.
Nicknamed Thor, this Agera is the second of two special final edition models. In addition to the machine's active aerodynamic system, Thor features a Le Mans-styled central shark fin to help cut through the air and aid stability at lightning-fast speeds.
The price barrier to entry is so high that a majority of people in the world can't actually afford it.
While not everyone can afford a Koenigsegg, the company's relentless focus on weight reduction paired with Thor's GPS-actuated suspension system and active aerodynamics, offer a technologically driven path forward for other, more ordinary machines. Supercars are explosive machines that captivate drivers and car fans alike. Vehicles that bravely chase the future while pushing ordinary automobiles to new heights.
There's a magic to it. The level of science and technology that has to go into it is just astronomical.
There are companies that put more of an emphasis on their supercars than others, and they're the ones that actually spend the time and the money and the effort to go out and develop new technologies and new materials and new things to make it better.
During the first few decades of the new millennium, the auto industry rapidly morphs. Shifting global economics and tightening environmental regulations force cars of all kinds to modernize. The push for change leads to a golden era for horsepower, where even basic machines suddenly feature nearly unthinkable power.
The horsepower gains of cars have ebbed and flowed and peaked and valleyed over the years. And why we're at a place like today where a base V8 that has 500 horsepower, like, that's insane.
Insanity is fully on display in 2010 when Mercedes-Benz's in-house tuning shop, AMG, introduces the SLS.
The SLS was that supercar in the truest sense. It was really expensive. It only had 2 seats. It had crazy doors that opened up. It looked like nothing else. It really was a showstopper.
The spiritual successor to the vaunted 300 SL Gullwing, the SLS combines retro pastiche with a brutal 563 horsepower V8 engine. The machine represents AMG's first car designed and built in-house. It's a small change that opens the door for other car constructors' in-house tuning divisions to build their own hot rods as well.
Yeah, the interesting thing with SLS, it was such a fantastic looking car, and it did so much with the way it had the curb appeal. I mean, when you saw those doors open, it was an amazing callback to the 300 SL Gullwing.
While the SLS is directly aimed at the higher end of the sports car market, in 2013, fabled Italian automaker Alfa Romeo decides to rekindle the magic at the other end of the equation. They introduced the 4C, the first truly affordable carbon fiber tub-based sporting machine.
It's an old school kind of car, right? It's small and it's light. It's got all this personality.
The 4C goes 0 to 100 kilometers per hour in just 4.2 seconds. Weighs under 1,000 kilograms thanks to a hypercar-style carbon fiber monocoque, and seduces the eye with outrageous Italian flair.
It's very clear from the second you get in a 4C, this is not a car that's trying to be all things to all people.
This is absolutely a less is more car, because the less weight you have to carry around, the faster you can go, the quicker you can corner, the more nimble the car is.
The 4C might be small and quick, yet its influence is enormous. The machine turns every moment into a track day, and every commute into a soul-stirring drive, yet costs no more than an average sedan.
It's, hey, I'm just as cool as a Ferrari. I'm just as outrageous, but I'm a third of the price.
You can save your money and get a beautiful Italian car made of exotic space-age materials that goes incredibly quickly around a racetrack and turns heads everywhere you go.
The 4C leverages supercar tech that was once solely reserved for mega machines, but is now readily available in more everyday autos.
It absolutely is a automotive trickle-down. Ferrari has been developing carbon fiber for a long time, but those cars start at $250,000.
The fact that you can get it in a car that costs less than 100 grand is nothing short of a miracle.
Beautiful design is a hallmark of all great sports cars, and by the 2010s, a refreshed take on British sporting arrives in the form of the Jaguar F-Type.
I think what's so surprising about the F-Type is how brash it is.
Even the modern F-Type is really quite striking. Whether you like it or not, it's just a unique looking piece of automotive work.
F-Type, like, this is the big, muscular, jag sports car that everyone wants, and it pops and crackles when you rev it. It's got a huge V8, and it looks like this.
The F-Type highlights the continued push in automotive advancement, leveraging a supercharged V8 that can produce 575 horsepower and hit a max velocity of 299 kilometers per hour. Supercar-like numbers in a high-end sports car.
Do you have any preconceived notions of a Jaguar being soft or pudgy or sort of humdrum to drive? You can throw those all out the window when it comes to the F-Type. When you get it out onto a racetrack or onto a twisty canyon road, it is absolutely engaging.
The F-Type looks amazing, and it sounds amazing. It doesn't have driver assistance technologies, and there's nowhere to put a suitcase. But like, man, like, it looks awesome. It looks so cool. Like, if you buy a 911, great, but why wouldn't you want an F-Type?
Four years later, in 2018, another mega machine is born mere kilometers away, the Aston Martin DBS Superleggera.
Aston's all about sports cars. It's all about luxury, grand touring, high-performance cars. You have things with big V12 engines in the front, and then rear-wheel drive, and then this just big luxury car interior.
While some supercars aim to be technical wonderkins, the DBS stands apart as the ultimate Aston and a new take on the mega muscle car aesthetic.
It's got a huge V12, it's loud, it's beautiful, it's expensive.
In an era of all-wheel drive supercars, the DBS is a throwback rear-wheel speed demon.
It's 715 horsepower, 900 newton meters of torque. It's clothed in carbon fiber, lightweight body structures. It has an amazing sound, a bi-turbo V12.
The imposing horsepower and high performance of the Aston Martin DBS is eclipsed a few countries away in Italy by the Lamborghini Aventador SVJ.
It's getting harder and harder because there is a physical limit on the power that you can give to the car.
The Aventador SVJ is a notable entry in the history of the supercar because it's born a little over a half a century after Lamborghini ushers in the high-performance sports car era with the Miura. It's perhaps the best example of an internal combustion Lambo, and also might be the last.
The romance is connected to the history, to the DNA of the engine. Frequencies, sound, vibration, these are all emotion. So we are at the high scale of the end. Therefore, that's why it's so special and so unique.
For the past half a century, the supercar elevates high-performance motoring and unleashes new tech on the road-going public. Yet with the dawn of the 2020s clearly in sight, what comes next might be even more profound. Supercars are works of beauty, engineering tour de forces, and machines built to battle science at every turn.
The thing that is so marvelous about supercars is this amazing combination of just absolute beauty and absolute power. And the fact that those two things can coexist on that level is what makes a supercar a supercar.
As the dawn of the 2020s approaches, it's clear that for the supercar and hypercar genres to survive, they must adapt or they'll perish.
We're coming to the end of the internal combustion engine period. So at some point, all of these different layouts are going to have to start dying off.
With the internal combustion era coming to a close, in 2016, Bugatti bends the laws of physics one last time and creates the ultimate petrol-based hypercar, the Bugatti Chiron.
You have this car that comes out, the Chiron. It's the Veyron on steroids. It's the Veyron with everything enhanced. Bugatti didn't need to make a car like everyone else did. Bugatti needed to make a new Bugatti.
The Bugatti Chiron is beautiful. Design-wise, they're absolutely extraordinary. They're exquisite.
It achieves its performance because of its excess.
The Chiron is the fastest, most powerful, and most expensive hypercar ever made, and the ultimate swan song for petrol-powered cars. A machine that bends heritage and stunning looks in one deadly high-performance package.
Really, what's most shocking about it is how fast it accelerates from like 100 to 200 miles an hour. It's astonishing.
It is perhaps the most ambitious and far-reaching we will probably get with an engine of that size, of that magnitude, of that power, the best representation of what's possible with an internal combustion engine.
When it debuts, the Chiron produces 1,500 horsepower, nearly 1,200 foot-pounds of torque, and costs a staggering $2.6 million.
The Bugatti Chiron is the world's first hypersports car to bring 1,500 horsepower onto the road with a W16 engine.
It speaks volumes to automotive engineering and automotive design and performance these days.
Technology makes the car an incredible statement for speed. The Chiron is built on a carbon fiber body tub, waves of microprocessors to manage all 16 cylinders and 4 turbochargers, and offers every conceivable driver aid available.
It's going to represent the last of the big internal combustion supercars.
As the last, greatest vehicle of its type, and a great swan song for the era.
Most evocatively, the Chiron delivers capabilities head-shakingly beyond what virtually any driver who hasn't raced Le Mans is capable of controlling at the limits. It's the very first hypercar to crack the 300-mile-per-hour barrier.
When you think about 300 miles an hour, it is largely inconceivable to the general public, but the physical stresses that your body is under are astronomical.
Creating a car that can drive 300 miles per hour is no easy feat. Aerodynamically, the downforce, lift, and drag all increase exponentially. At max velocity, the tires spin 68 times per second and have to withstand 7 tons of force trying to rip them apart.
You're never going to have another internal combustion car that's going to top what Bugatti has achieved with the Chiron.
The Chiron goes down in history as a pioneer that ventures into the unknown, thanks to the incredible engineering underlying the machine.
It is comparable with Greek mythology, yes. It is the end of the internal combustion engine.
The 300-mile-per-hour mark has loomed in humanity's automotive consciousness for over 100 years. The immediate question is, what comes next?
The piston engine would start reaching its point of diminishing returns. There's nothing that gets you around a track like an electric motor, initially supplemented by a piston engine and then eventually completely doing away with the piston engine.
The art of aerodynamics and hybrid tech takes a massive leap forward 2 years later, in 2018, when McLaren drops the Speedtail. Inspired by the company's seminal F1 from the 1990s, the Speedtail is the marque's fastest and most efficient machine ever created, with a top speed of 250 miles per hour.
Right now, we're fighting for 0.1% for performance. If you can move body parts around to take advantage of Air Force, well, then you've got a handling advantage over someone else.
As manufacturers wring increasingly marginal gains out of engine tech, aerodynamics offer the greatest potential for significant speed increases. The Speedtail's importance lies in its unique aerodynamic innovations, including static carbon fiber wheel covers, cameras in the place of side mirrors, and hydraulic elements that bend the carbon fiber bodywork at the rear of the car, to create a seamless rear wing.
The aerodynamics are so incredibly important because everything is the result of downforce and aero, and the lowest amount of drag that a car can have when it cuts through the air means it can go faster with less power.
The Speedtail is the latest in a long line of super machines that seek to make their mark, not with more power, but rather better aero. Most supercars these days are envisioned from the start as an inverted wing, where the fastest air moves over a low, sleek body, and the slower air moves underneath the machine. This vacuum helps suck the car into the road.
Aerodynamics are really important. When you get into the 600, 700, 800 horsepower range, the top speeds of these cars are so high that if you don't get the aero right, they could be really dangerous.
The biggest limiting factor for a supercar's top speed is what is known as vortex wash. This is when a car is traveling at speed and fast air passes over the body before curling back over the rear end. The disturbed flow is known as dirty air, and it upsets the downforce on the machine.
So there's a delicate balance between making the car slippery enough so that it goes through the air at high speeds and making it not take off.
It's tempting to think that aerodynamics is a mature science. However, advancements in computer modeling are offering new solutions that bring supercar builders one step closer to reaching the holy grail of maximum downforce with minimal drag. As the automotive industry enters the 2020s, it's clear that the age of the fully electric supercar has finally dawned. Introduced at the 2016 Geneva Auto Show, the all-electric Rimac Concept 1 puts major automakers on notice that change is coming in the supercar space. Roundly considered the world's first fully electric hypercar, the Concept 1 goes green in a major way, thanks to its mega 1,224 horsepower powertrain. The machine relies on advanced all-wheel torque vectoring, which uses the car's data to adjust the power output at each wheel independently and in real time as it's driven, giving the machine considerably better grip than most conventional cars.
They're automobiles that have maximum torque right out of the gate.
Once an anomaly, supercars powered by electricity are redefining what it means to be extraordinary in the modern age.
Supercars have reached a zenith of what's physically capable. And I think the evolution is how to take that performance and adapt in that same fashion, or else they're going to hit a ceiling and in doing so become irrelevant.
In the past 2 years, dozens of high-performance vehicles have emerged on the scene. Yet powertrains with 1,000 plus horsepower and top speeds in excess of 200 miles per hour are now commonplace. The question is, how to bravely go even faster.
The supercar era is going to have to adapt and evolve. You have the best and brightest minds creating the most impressive feat of engineering with no room to grow because it's so singularly focused.
Electric cars have a lot of benefits in terms of performance. Got low center of gravity, tons of instant torque from an electric motor, and if you combine that with chassis engineering, steering, all that stuff, you can really show people that EVs can be performance cars.
An electric car is the automotive equivalent of speaking softly but carrying a big stick, because it's not very loud, it's not raucous. It's a car that's quiet and is quietly sophisticated, but that doesn't mean it can't pass you going 250 miles an hour on the Autobahn.
Supercars live in a realm of fantasy. While they may not be practical, they're more than just performance statistics. They're aspirational objects, engineering masterpieces, and mechanical art. Qualities that hopefully translate in an EV world.
Electrification is good, and it's good for performance, and it's good for supercar development. And it's going to be great because companies are investing a lot of money into the development of electrification.
As platforms for first-time engineering audacity that can later be applied to more affordable vehicles, supercars offer all of us a bold potential look into the future of the automobile.
The powertrain is becoming less significant in the electrification era. Well, if you can buy the batteries and the motor off the shelf from any car company or any company willing to sell you the stuff, then the freedom to create the car becomes a lot greater.
Once people realize that electric means torque and torque means power, and if we can put electricity into this car, it's going to just get a crap load more torque. That's a good thing, right?
With electrification, we will see many more startup car companies producing high-end electric cars with the hope of maybe becoming a Tesla and eventually building affordable cars, but they start at the high end.
Special cars devoted to high performance have existed since the dawn of the motorized age. In the 1920s and 30s, wealthy thrill seekers pushed Bentleys and Bugattis to the edge. In the 1950s, speed seekers climbed behind the wheel of a Jaguar E-Type or Mercedes-Benz 300 SL to topple records. And in the 1960s, the Lamborghini Miura sprang into existence, and with it, gave birth to the supercar genre. Today's hypercars and their all-electric brethren are stretching the boundaries of the automotive universe one step at a time, bending the laws of physics as they go, and helping to create a brave new high-performance world for all of us.